Live on YouTube and Twitch again for another beautiful day of coding here on planet Earth. It felt so nice outside. I kind of just wanted to stay sat out there and enjoy the very mild weather, but we have some Odinmade Hero to do. Last night when I wrapped up the stream, I was trying to finish up implementing this call with Casey, and we got it working. You know, there wasn't really anything too interesting about that, just moving the code into something we could reuse, and we got our hero's head here, the Odinmade hero now. But of course, we have this black rectangle that kind of makes up the entirety of the dimensions of the bitmap that the hero gets right in with, you know, his head along with the dimensions of this whole bitmap. So we're rendering the whole thing out so the alpha isn't, you know, being represented properly, but I think that's something that we'll get to today. You know, this draw bitmap call really wound up being quite similar to draw rectangle. In fact, that's what we were in the middle of doing. That's right. When we wrapped up last night, just yanking the draw rectangle code into here, into draw bitmap, and then rather than having the bounds of the rectangle pass to the procedure, we pass the offset X and Y into the buffer where we want to draw, and then we just draw out the dimensions of the bitmap. So, and then that just reuses that code from drawing the rectangle, but we're going off of the bitmap's dimensions where appropriate. So that really wasn't the interesting part of the code last night. Not really. The really interesting stuff was going on here in this load BMP proc that I've been slowly working towards finishing. And I think we'll flesh it out a bit more today, but I actually don't know how much more I'll need to change it, if at all, really, because we can see that when I run this, it looks like the colors of our hero are correct. You know, he doesn't look red or blue or anything improper, which is good. For whatever reason, when Casey loaded him in and then started drawing him out, he was red, like he had a very like he got a red flower, a fire flower, and got like a power up, and so now he's all mad and upset with all this power. He's gonna go hurt some fools. So I can only assume that if I had stuck with my original approach, or one of the approaches I was thinking of going with, which was just OS read entire file, and then start pulling, you know, out the necessary attributes of the bitmap from the header, all that stuff, that would have led me to, I think, having the same result, because not only would we have had to start drawing from the bottom row of the bitmap data instead of the top, like we were able to because we're using this proc, but we also probably would have had that color stuff going on. And now I don't want to jump too far ahead, but I have skimmed because I really wanted to hammer this stuff home for myself and make sure I understood what was going on. And I'm still not totally sure about everything, but I can at least explain where these changes I've made now have come from, and demonstrate how awesome Odin's array programming is, because I finally got to use it. I finally had a use for it, and I didn't even see it. It should have been obvious to me last night when I was implementing this out, but it wasn't for whatever reason. Because I think I was just stuck in, like, how do I do the bit shift operations, which, you know, I'm not competent enough to understand how to do all of that. And then, you know, when I was skimming ahead, I could see that Casey actually dives deep into that stuff in day 38, where we do basic linear bitmap blending. And so I think, we'll dive pretty deep with that. And so it might actually wind up being a relatively easy day for me, at least until we get to the actual linear blending, I think. And once we get to that step, I'll have some work to do, but it still will be pretty easy again, because Odin's array programming just makes this so awesome. So I decided to have this header on the bitmaps metadata stick around, accessing that union and then the info member off of the BMP info struct. So that gives us all of this that we can refer to as needed. And there's some stuff in here about, I think, compression. And then, of course, we talked about the color space yesterday. That'll wind up being more important later on. But then I also added this debug code because I wanted to be able to print this out on demand, but I didn't want to be commenting the code out. So I just decided to throw it in a when Odin debug block so that I can see, which BMP successfully loaded, the color space that bitmap is in, and then the masks, which will come into play a little bit later, even though I don't think I'm going to use them because I don't think I need to. And then, of course, we add the alpha channel if one is not already there, just so that we're always operating on a 4-byte wide color pixel. We get the pixels out of that bitmap's pixel buffer and store it in our resulting bitmap struct. Same thing with the width and height. And then here's where it gets kind of fun. This is the thing. So I was pulling each individual pixel out into a slice of U8, I believe. Like I was just kind of naively taking, pixels and then, everything at the pixel index on to get, basically wherever we're at in the bitmap pixel buffer, I was getting a handle that's a U8 slice to all of the rest of the pixels in the buffer, depending on where we are inside of this nested for loop here. And it just, for some reason, it didn't jump out at me at the time, but I started looking, at some other examples of doing bit shifting and manipulating pixels and colors and all this stuff, both on the internet and in the Odin Discord. And that was when I realized I can just use Odin's array programming for this. I can pull out, I get a reference to each pixel at that pixel index, which is really what I was ultimately trying to do, but I was just, my brain has been stuck in slices this whole time, since I started streaming this project, and I couldn't, for whatever reason, my brain wasn't going to like a fixed width, pixel that's 4 bytes wide, representing, 1 pixel and the colors therein. So now I take a reference to the pixel at each pixel index as we're walking the whole bitmap, cast it to a reference to a 4-byte wide array, and that gives us the individual pixel that we care about. And this is the thing that I was kind of struggling with yesterday, and even before the stream yesterday. I was like, I couldn't make sense of why, even though the color space, and you see now I have this switch statement on the header color space member to tell me which color space we're in. I couldn't figure out why it said we were in the sRG color space, but it seemed like the red and blue channels were swapped. So I guess what I mean by that is if I leave each pixel alone, which is what this assignment would do, right? We're just grabbing the red, green, blue, and alpha channels in the same order that they are stored in each pixel and assigning it to the dereference pixel, where we're at in the buffer. So if I build and run this now, we'll go back to what I was seeing yesterday, which is like everything is blue, and now we can actually see, instead of our guy being super red and angry, he's blue and sad and cold. And that's a bummer, right? So I was like, why is RGBA, if this is the order, if this is the color space that the bitmap is in, why does RGBA why does not, in my head I was thinking it should already be in the right order, is what I guess I'm trying to say. And that was when I realized this is telling me that the order Let me think about this. I thought that this was telling me that the data in the buffer should already be in this order. But what it's saying is that to lay it out in memory so that you get the value that should actually be represented by the thing, when you go to look at the actual texture in your, whatever asset viewing program you have on your machine, that is the order that things need to be laid out in. But by default, Odin is going to store each value in the channel that it's supposed to be according to Odin's arrays. And it just, I think I finally got that right. We have the red in the position that's supposed to be on this, 4-byte wide array, according to how Odin would understand where the red should be. Same thing with the green, same thing with the B, same thing with the A. And I wonder if I can actually look at the docs real quick and confirm this. That's not what I wanted to do. Odin.
Okay. Hello, everyone.
Now Casey's talking. I didn't mean to do that. And I'm on the complete wrong day now. Hold on. Not yet, Casey. Why is this so much effort? Here we go. So I go over to the docs, look at, I think the overview should have what I'm looking for to help me explain this. Go to array programming. And we go down to swizzle operations. Okay, here we go. Now if we look at the docs, sweet, it brought up the right window. Hey Devil, I'm just making sense of all of this array programming stuff because it's pretty powerful, and I finally have a use case for it at the place where we're at in this journey. And so I'm trying to make sure I understand what's going on with respect to the whole bitmap loading thing. That's all we're doing. So if I zoom in here, you can see that swizzle operations on arrays are kind of like a killer feature here for the language for me. I mean, it just seems so useful because a lot of the time you have to hand roll this stuff yourself or use a library that does it, and then different libraries don't always have the same understanding of how this stuff is done in memory and everything. And so you can see right here where it says, is that actually showing up when I highlight that? It is. So it says built-in implicit swizzle fields are available on any array with length less than or equal to 4 as X, Y, Z, W, and RGBA. So it finally makes sense to me that Odin is just storing each channel and its respective member in the 4-byte wide array, but the representation in memory that we want to write it out into a frame buffer as, it needs to be in ARGB or sRGB. And the way to do that, right, is to swizzle this pixel so that we get sRGB. And what this confirmed for me was that it was the right choice to stick with Odin's built-in BMP package, even though it's not completely finished, and I'm sure there's features that the contributors to Odin want to add. And maybe if we get to a point in this series, or ever get to a point where, there's something about the image package or the BMP package that I feel I could contribute to, then that might be something that I start doing at some point, but I'm not quite there. The point is that this is pretty awesome. It leaves us off actually in a place where we're not going to have to do some of the stuff that Casey's going to have to do to get the colors looking the way they should. And so that's what he's going to cover, but he's going to go into depth about how to implement this ourselves, and I don't really necessarily feel like I want to go out of my way to solve this for myself, but I still want to pay attention and make sure that my understanding of this is correct. But basically what's happening, right, is that the BMP package is doing a lot of heavy lifting for us by getting the RGB and A values into the place where they need to be for us to be able to then just easily swizzle the pixel to get it in the memory order that we need to be able to draw out to windows correctly. And then what the switch statement will do is that if we get some assets that aren't laid out, in the sRGB memory order, then we would swizzle it according to, Windows color space, which I don't even know like what that is. I tried looking at like what is the actual order, like is it, you know, is it more like this, like A RGB like that, or is it just RGBA? I guess this would be A BGR. So I'm just gonna leave that case unhandled for now, and then we'll see. I don't know if this switch will just blow up the program if we do get an asset that doesn't have this color space, but I'm not too worried about it right now. I'm just happy that this is working as well as it is, and even better than I could have hoped for. Yeah, we're finally swizzling. It's awesome because you'll see how much work Casey has to do to get this to just happen the way that we can use Odin's, you know, built-in core features to just mess with the order of, you know, the red, blue, green, and alpha channels. It's not fun work, and I've done it twice now, both in, actually I don't think I ever did it in C, but I did do it in Zig, and the whole time I was doing it I was just completely lost and just, you know, trusting the process of working through it. But now a lot of this stuff is really sinking in, and I can really follow what's happening to the point where I can even try and use another library. And I think that's really the point of this series that Casey wanted to get across. I think that's what he wants people to take away from it, or at least that was his original intent when he, you know, started doing these streams 10 years ago, is that, you know, you should be able to implement it yourself, or at least be able to follow an understanding that goes from A to Z with implementing it yourself. So that way, when you go to use another library, exactly like what we're doing now by using Odin's core packages, I can follow the steps to get to the place where I want to be, which is we're drawing out these textures correctly to our frame buffer. So with all that being said, I'm going to let Casey take it away. If I can get this set up right so we're looking at the right day. And so yeah, this should be just like a kind of a day to reinforce things. And then we will, I think, get to a point during this stream, at least where I want to get to over the course of the stream, is, you know, doing the alpha, the linear blend correctly, so that we don't have this floating head in a void. We can actually draw out the hero onto the game screen correctly, and that'll be good. Another good milestone to hit. So let's go. A bit of a preemptive start to the recording, I guess.
Crisis averted. Yes, the crisis has been averted, HNAU. The crisis actually has not been averted, unfortunately. The reason that the stream is starting late today is because, well, we're having a little bit of a problem. I wanted to get rid of my taskbar. I was talking about this on the last stream, and I thought I had seen some people say that you could finally get rid of the taskbar again. You used to be able to get rid of the taskbar on...
There's just... I can't help but laugh whenever he gets frustrated by something, the exact sort of thing that I would get frustrated by, and then just spend like an hour trying to deal with, or even hours just trying to deal with something as simple as hiding the taskbar.
Windows XP, and of course when they introduced their improvements to Windows with Vista and 7, where they improved everything, they improved it so that it no longer works. So you can't actually hide the taskbar anymore. Basically, you only have this thing that basically it always pops up if you go back up to the edge of the screen, and it's awful. And so you used to be able, there was a thing in here that said taskbar is always on top or whatever, and you could uncheck that, and that was awesome. It was like totally perfect and did exactly what you want, because then all of your full screen windows would just be over it, which is what I wanted. But I don't know what to say. So basically, I was trying to get rid of that. I was looking on the web for some of these things, basically, and yeah.
That is not what's happening. I had to look up what that meant. I don't even know how to pronounce that. Schadenfreude. I'm sure it sounds something like that. But I am not expressing pleasure in response to another's misfortune. That's not what that is. That is empathy for something that he is going through, which I go through myself all the time. And it's a terrible experience. It's commiseration, you know, across 10 years of life experience and difference, and wherever he is now, I'm sure he still deals with problems like that all the time, because it's just an unfortunate part of experiencing life with software. It makes you feel like you are not insane by being annoyed by it. Exactly. It's the fact that somebody else goes through this too, and I know everybody does. It's just people don't talk about it, and I feel like we should talk about it. We should talk about how insane it is, how much we put up with when software just like gets in the way of doing the thing that you want to do.
Yeah. Couldn't find it. There's like some tools. Of course, they got rid of it so thoroughly that you have to see taskbar always on top, Windows 7. And like I was trying to find people who were talking about this sort of thing, and there's like utilities you can install where I tried installing one of them, but it didn't actually work. So basically, like, you know, when you're not using the trackbar start menu, blah, 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 right, it simulates to keep taskbar on top, unchecking that box. This is what I actually wanted. They're like, I've been surpassed. The 7 plus taskbar tweaker does this job better than my code, and I recommend you install instead.
See, like somebody had to make a whole web page to try and he made a tool. This person made a website and a tool to support others who want to mash their taskbar. And then there's this picture of a dinosaur stepping on the Windows logo. Like, there's a lot of things going on here that transcend the time and place where the stream took place.
I installed this. I do not actually see any option for doing it, so I don't know if I'm just using the tool wrong. I haven't tried this one yet. I guess I could try it just to get a few more viruses on my machine, you know? It's always good.
And the great irony here is he just had to wait 10 years, you know, because it's 2024 and I can hide my task manager on Windows 11 or whatever version of Windows I'm on, you know. And I know I'm some kind of peon, you know, just amateur loser for using Windows 11, but I've been using Windows since Windows 98. Yeah, it sucks. I've used Mac a lot. Mac kind of sucks sometimes too. I haven't really used Linux as like a desktop experience, although I've done tons of development, you know, with Linux machines through like terminals and stuff. They all kind of suck for their own reasons. Took JBlow's advice on collecting a list of bugs in software we encounter every week. Yeah, I've seen that talk that he does, and he's right. He's the only buddy. He's the only buddy. He's the only he's the only he's the only person who cares enough, right, to talk out loud about these things. And I think that those issues, because they plague people who work with computers fundamentally more than like your average person, it just feels a bit out there. But now so much of our lives are inundated by, you know, I got to log in, so I got to look at my authenticator. I don't want to rant about this all stream long. This will be the last. I'll let Casey get through this showcase of his struggle to get the task manager to hide. But the point is, it matters. Your pain matters when you're dealing with software and computers, and it's wasting your time because you just don't know how to do the thing. It matters. Your lost time should not be in vain. We should do something to fix this, all of us. If you build the internet or build software for a living, you should endeavor to fix these things, not add to them.
Don't actually know, if it would actually work. I could try it, and I just don't understand why this guy thinks that this tool does it, but he doesn't actually say how you would do it. You can see here, like, I've got this thing installed. If you open it up, right, I don't even see an option for it. I don't even see a heading where the option would go. But I don't know, like, there just doesn't seem to be. I got nothing. There doesn't seem to be any actual thing here to click on. You know what I'm saying? You know what I'm saying. Does anyone know? No one on the stream probably knows, because I'm guessing that people on the stream probably have already moved to some other thing. I should probably try to install Classic Shell and see if that has it, or one of those other shell tools, and see if it, you know, can replace this whole taskbar with something more usable. But yeah, so he says install 7 plus taskbar tweaker. Here is 7 plus taskbar tweaker. I do not actually see any options that actually would work. Dropping, hovering, thumbnails, pin, left click, other, hide the start button. That actually does hide the start button. That doesn't help. Show desktop button can go away. That doesn't help either, although I'd be fine with having that go. I never use that button. Display seconds is good, but doesn't help here. Reserve empty space doesn't help. Doesn't do anything. In our case, I don't know. I guess I could look at the help. Maybe the help has something. Let's see. Search. Top. Some of these send options to tune aspects of the tweaker. Disable topmost. Oh. Wait, so it does have a setting. But
I'm going to spare all of us because I'm pretty sure he just is not. He goes through all of this and he still can't figure it out. I'm going to jump like into the actual coding portion that we care about. I didn't realize. So he bundled in the pre-stream here where he's struggling with Windows Task Manager and making it go away, or the taskbar or whatever.
excited about that. Let's get all this stuff straightened out again. That means we no longer have this ridiculous unused area at the top of the screen. We can
Oh, he did figure it out. He did figure it out. Good job, Casey.
actually have everything go up to the height that it was supposed to be. Let's see, does our Emacs go to the whole? Look at that. That's fantastic. Well, that is just great news. I'm very happy about that. That is super cool.
I actually have had the same issue. It took me a while to figure out how to like full screen my terminal emulator so that I wouldn't have these black bars above and below, you know, on the stream. And when I full screen now, I don't have that problem. Although I'm not seeing it in front of me, of course, now when I swap between full screen and not. But it's incredible how long it took me to figure that out. Yeah, he should have just made his own OS. That's what all of the Linux community does, right? They make just their own, you know, distribution of Linux, and it's got, you know, these great things that work for them, but then there are all these other problems that they could never foresee, right? That other people start experiencing once they start using that distribution. And then the, you know, the people that made that slightly different distribution of Linux just go, well, I never needed to do that. You know, that was never my problem that I had because I don't do the same things you do. It's a problem that keeps on probleming.
You know, it's the little things. You know what I'm saying? Even if someone else had to write them for Microsoft, at least someone did. There we go. All right. I guess we can start the stream now. I hope everyone shared in that triumph. I don't know if they did or not. Can't see what's going on there. Yeah. Yeah. I think everyone's pretty excited. I know I am. So let's go ahead and get the gloves on here, and we will go ahead and start the stream now that we've had that small victory. I guess I can close the old command prompt from yesterday as well. Get back to our standard screen, and we can actually get programming, which seems like a pretty good idea since this is supposed to be Handmade Hero, not Handmade fighting with the Windows user interface, get the taskbar out of the way. Even though sometimes that is what programming ends up being. Fighting with Microsoft to get it out of your way is often a thing that does happen when you're programming, so, you know, it's not...
Sometimes it's just trying to understand how S3 expires and deletes files. I spent like 2 days in the last 2 weeks just trying to look at their documentation. It makes sense of all the little dials that I have to tweak to get a file to expire after 1 day. And I also don't understand why it has to be in days. Like, why can't I expire and delete it within 10 minutes? Now I got to go and write my own custom code that runs all the time and checks, you know, every 5-10 minutes or whatever if I want a file to be deleted sooner than 1 day in the future. Why on earth? Nintendo Power Gloves, programming gloves. I'm pretty sure they're like wrist braces because he has, I'm guessing he has like carpal tunnel, and I'm assuming that the wrist braces help him with that. I've never had that problem, but I'm only 31, so, you know, maybe I'm still young and I'll have that problem before long. But I don't know if he does that forever, or maybe he gets like a better keyboard that is more ergonomic at some point. I really don't know.
Not that far off, I suppose. But let us go ahead and return to the program. Hello, everyone. Welcome to day 38 of Handmade Hero, the show where we code a complete game from scratch using nothing but our typing little fingers, no libraries, no engines, so we can actually see the complete process of making a game, and you can learn how absolutely everything works, right from where the pixels are drawn on the screen all the way up to how the game code operates at a high level. So today we happen to be at the point where we are putting sprites on screen, and we are not doing our full renderer yet because that's a little bit more of an involved process, but basically we just wanted to have something where we could easily put some graphics up on the screen for our own testing purposes as we are sort of going through and figuring out what we want in our engine architecture. And one of the big parts of that obviously is going to be what we want for our rendering architecture, and it's kind of hard to make those decisions without something to work with. So that's what we wrote yesterday, but we have a couple things left that we need to do to it, so that's what we're going to be doing today. If you'd like to follow along at home and you went to handmadehero.org and pre-ordered the source code, you should have gotten a link in your email address, in your email inbox. And that link will allow you to download both the art assets that we're using, and it will also allow you to download the source code. So if you download that source code, today is day 38, so go ahead and unzip day 37 source code out of the source code zip file. So zip file basically has a ton of little zip files in it. It's like a Russian nesting doll kind of a thing. And there you go. That will basically give you the same source code that I am starting with right now. So let's go ahead. We've got a bunch of stuff to do, so let's get to it. I'm going to open up the debugger here and just point out where we were before. If you remember, we were looking at putting the sprite up on the screen, but the colors were wrong. And so the question was what was going on there. And it turned out that since I think it was my fault, actually, I had run a little resizing tool on some of the, I'd run Image Magic to resize some of the bitmaps, and it wrote them out in a different byte order than the ones that came straight out of GIMP. And so basically what we have to do today, we figured out this at the end of last stream, that basically the bitmap header has these things at the bottom, red, green, and blue maps that we figured out, and we've got them laid out in here so we know where they are in the file as well. That basically...
That's right. I couldn't remember if he got to that in the previous stream, but basically I'm able to pull those masks out as well. And so I have this, you know, debug message where I just write them out and I say, here are the masks. But because I can just use Odin's blessed array programming to swizzle the byte order of the pixel to get the colors and the channels I want them to be in, I don't have to really mess with the masks. But again, for posterity, I have to make sure that I understand, really truly have a good understanding of what's going on here, because if it's not BMP, right, it could be any other file format, and there could be other peculiarities that, you know, make you want to care about the actual low-level details going on here.
Tell us where the red, green, and blue components go, and it's, I guess, assumed that the alpha is just whatever these aren't, because there's obviously an alpha component as well, and there isn't an alpha mask parameter as far as I can tell, although maybe there actually is in an extended version of the file format, I'm not sure, but when we were looking on the website of the documentation, it looked like it was only red, green, and blue. But it doesn't really matter, because we can tell what the alpha is, because it's where the red, green, and blue isn't. So, what we need to do here is we need to, I don't know if you remember this, but basically we already were doing a thing where we were swapping around the order of the stuff that came in because it wasn't the order that we wanted. So our pixels were packed with ABGR, which is this thing right here. And so this is actually not correct anymore. This comment we've learned is erroneous. And so basically what we need to do is change this to say what's actually going on, which is the byte order in memory is determined by the header itself. So we have to read out the masks and convert our pixels ourselves, right? And so that's what we're going to have to do today. So basically now we assume that when we...
So maybe I can just put in a note here for myself, because I think I got rid of any comments I had on this. So right, where did he put that? He put that, yeah, just above where he's diving in and doing his own swizzling implementation, right? I can say note byte order memory is determined by the header. I think that's still true here, or at least we can say that the byte order memory can be found in the header. I don't know if the header determines it or if the header just observes that information in the layout of the file, right? So we can use Odin's array programming to swizzle each pixel according to the color space we observe in the header. And that's literally what I'm doing here, right? We do a switch on the color space. We're all, you know, out of all the assets that I've read in so far, they're all sRGB. So we then just swizzle it to get the blue and the red swapped around, because I think, well, there's something else going on here. It might not just be that the red and blue channels were swapped, right? Because that's like the default. It's actually more like kind of the same thing that he was seeing, but it doesn't explain, well, maybe the swizzling that he's doing here would work for one asset but not another. I don't want to belabor this too much, but the point is it's not just that the red and blue are swapped. Or is it? Is that right? It is actually, right? Yeah. So RGBA becomes sRGB or BGRA, and that gives us the result we want. So yeah, never mind. It is just the red and blue channels needed to be swizzled around like so. So there you go.
Load one of these BMP files. We have no idea what order the things are in, and we basically have to go ahead and figure out where they are. Now we could, we know that basically none of the files that we're saving are going to have anything other than 8 bits per channel. So we do know that we're basically looking at an OXFF kind of a mask, but we just don't know where it actually is in the 32 bits. We don't really know where it shows up. So what we need to do is we basically need to get a shift value for each of our components. So if you think about it, we basically have a redshift, not to be confused with the kind of redshift that they use in astronomy. Obviously that's a different kind of redshift, but we have a redshift, a green shift, a blue shift, and an alpha shift, right? There we go. And so what we're going to have to do is we're going to have to figure out what those are, and then we're going to have to come in here and actually get them out, right? And so when we actually build our thing, we could make this a little simple by taking the actual color value, grab that, and then we could do it this way, just make it a little more easy for us to write here. We basically can figure that we know we need to pack things such that the alpha is on top, then the red, then the green, then the blue, right? So what we need to do essentially is we need to shift the red. Well, you know what? Unfortunately, I don't know that there's really any way we can do the shift totally generically with only one shift. I'd have to think about that, because really we need to shift it. It could have to shift in either direction, right? Where the red is in our source. I don't know if you guys are already on the same page here in terms of what I want to do. But basically, I've got something where I've got a 32-bit value, right? This is my 32-bit value, and essentially I've got the 8s here. This is 8 bits, 8 bits, 8 bits, 8 bits, right? This is the low, this is the high. And basically what I need to do is I've got, some set of things. I've got the red is somewhere, the green is somewhere, the blue is somewhere, whatever. So I've got my A, B, C, D, and I basically need to rearrange these, right, in some arbitrary way. Like I have no idea where they actually need to go, but I know that I'm going to determine where they need to go. So what I need to be able to do is I need to be able to mask it out and then shift it to the right location, but I don't actually know which direction it's going to have to go. It may be that like this was the green before and the green now has to go here. So the shift would actually be a left shift, right? It'd be getting higher. But it could be the other way around where it's actually below, and so it's actually going to be a right shift, right? And since I don't actually know if there's really any way to write that concisely, what I think I'm going to have to do instead is first shift it down and then shift it up. So I know that my shifts are always are always going to be to the right for the parametric amount. So basically I'm going to take the C and I'll shift it down by the alpha shift value, right? Whatever that alpha shift value is. I will AND it with the mask so that I know that I've basically now just got the alpha sitting in the low 8 bits, and then I'll shift it up by 24 to put it in the position where I actually want my alpha to be, right? So that is basically what I'm going to do for each of my values, just so I can, usually, a lot of times people call this like a swizzle. I'm not really sure why they call it a swizzle, but a lot of times they do. So I basically want to get the red, the green, and the blue by shifting them down like this, masking them, and then putting them back into the place where I actually want them to be, like that. And so really all I need to do here is figure out what the shift would be to get whatever the value is down into the bottom, down into the bottom 8 bits. Problem is I don't actually have that. I have the mask. And I don't have an alpha mask technically, right? Ooh, hello, that was odd. What I actually have, I've got the red mask, right? That comes out of the header, red mask. I've got the green mask. I've got the blue mask. But the alpha mask actually isn't there, as far as we know, right? I don't actually...
So something kind of nice about Odin again, and this BMP package that we're working with. And really just the whole image, I don't know if it's like a sub-collection or a sub... or if it's more of like a parent package, and then BMP is like a sub-package again. I need to try and understand that nomenclature a little bit better. But if we look in here, if we look at masks, we actually get a mask for every single channel out of there. But then what he is essentially driving towards is we have the mask, but we still don't know the shift. So he has to go and calculate the shift. And basically, it's my understanding that he's implementing his own swizzling, right, to get these values in their respective channel in, the byte where the red is, the byte where the blue, the green, and the alpha is, and just moving them around. And he's implementing this by hand, and it's a thing that Odin has already done for us. And it's generic to where anytime we have, a 2, a 3, or a 4 byte wide array, and I think it's not, exclusive to just bytes either. It's any array where there's some value stored in this array, as long as the width of the array is between 2 and 4, which is kind of awesome.
Have an alpha mask. So what I'm going to do is I'm going to assume that the alpha mask is just wherever there wasn't a red, a green, or a blue. So if I OR the other masks together, basically make a composite mask that would mask for red, green, and blue all at the same time, I'm going to assume that the not of that, if I flip all the bits in that, then I'm going to get basically where the alpha is, right? Because that'll basically give us wherever the other ones aren't, right? And I'll dummy up these values for a moment just so I can show you what I'm talking about for those of you who may not be super comfortable with bit operations yet. I think it's amusing actually, but
Yeah, I agree that swizzling is not super hard, but it's the fact that he has to, it's the way that he's having to go about doing this based off of these masks to calculate those shifts. You'll see what he has to do. He has to go to kind of a length here and write some custom code, and then on the one hand, I think he implements something that'll work cross-platform, and then he also calls like a Win32 function to be able to get the shift value out of the mask, and that is the pain because the byte order can be different each time, so he has to make it work generically for wherever each value is stored in each channel.
I think someone was actually
and it's not just that it's not about swizzling being hard or easy, it's the fact that it's baked in, right? And so therefore any library can use that functionality in the language, and it'll work the same across packages, right? It'll work across libraries, and that way if two libraries have an understanding of 4-member wide arrays, they'll treat that memory the same, unless you start implementing your own custom distinct types and doing some different stuff there. But that's I would hope that if you're making a library that's intended to be used by a bunch of different people in Odin, something that's really easily reusable, you would be using Odin's that strength of Odin. To me, it just seems really, really powerful, regardless of like what the implementation is. I was just pointing that out because that is what Odin is doing underneath the hood, right? To make life easier. And it's also just how easy it is to use. It's not just that it's the same and it's a common underlying feature of the language that can be used everywhere and everybody's understanding of it will be the same. It's just, I call, RGBA, if I swizzle those members around, right, and call them in any order to get the swizzling done, that is just super neat to me. You still need to do it in Odin. Well, I mean, look at how easy it is, right? That is the swizzling. I don't have to implement it myself. I just call these members. That's my whole point. It's really easy to do.
Asking just on like a stream like yesterday or the day before whether we if bit operations normally get used, and today is like all about bit operations, right? So the answer is definitely yes. Anyway, so if we read out the red, green, the blue mask, you can see them here, right? There's the red mask, the green mask, and the blue mask. That's saying it's basically the red's in the high, green's in the second down, the blue's in the second from the bottom, and the alpha we don't know. We don't get that, right? So what I'm going to do is I'm going to OR them all together, which will basically produce OXFFFFF, right? And then I'm going to knot it. So you can see that basically what I get what the part is that isn't filled in any of these other ones, right? And so that's what I wanted. I just wanted to fill in that extra value, right? And I can do that a little more explicitly if you guys want, just to see what I'm talking about here, right? I can do it in 2 steps. I wish they allowed you to step into an expression. It'd be so much nicer. God, all the things debuggers could do and don't. So there's the alpha mask first before I've knotted it, right? You can see basically if I OR them together, I get the composite of all of those masks basically, and then the knot just flips what the actual values are, right? So that's what I was doing there. So that gives you all the masks, but now we have a problem, which is basically we need to actually know essentially what the lowest bit is that's set in these values, right? Because we need to know how far down to shift, so we essentially want to count how many bits there are that are
Another thing I wanted to point out too, keep cutting them off. I want them to get through this so that we can get to something where we don't, where I have to actually write some code. But if I dig in here, I think into the load proc, let me go to load from bytes. Down here. So once we start dealing, I think with the format of the byte order. So we have this to do to handle RGBA, which means, I think if we got an asset in that used that format and didn't have a header that talked about the bit fields and the alpha bit fields. Casey kind of goes into this at the end of the last stream, I think, either just before the Q&A or during the Q&A, where like this is kind of the stuff that's being done for us underneath the hood in Odin's BMP package to make that swizzling just work, right? So Odin is providing that out of the box for me. I didn't have to go, and figure out how to do that parsing of the BMP. Like, you're right, if I was to do this from scratch in Odin, I would have to go and do the work of parsing the header out, right, of the BMP file and do all of that work from scratch, but I don't have to because I'm not going to do it as well or in as nearly as much time, efficiency as the Odin people are doing it, right? So the BMP tells me what format the memory needs to be in, or rather the result from that BMP load tells me that if I want the byte order to be correct when I'm writing things out to the frame buffer, this is the way that I need to swizzle things in, right? Because if we just left it alone, and I'll just comment this out, I guess. It's going to complain at me because I'm not using that pixel variable. See, if we left it alone, if we didn't swizzle it, then we get this blue hue to everything, because red and blue are switched. So like the array swizzling is baked into Odin, but Odin is also providing us this nice BMP package out of the box, which will do the work of parsing it and making it very easy for us to write it out in the order that we need to write it out in to get it to present to the frame buffer correctly. And so I actually wrote very little code, but I had to make sure I understood what was going on well enough to be able to do this much, right?
0, starting from the first bit and going up to the very first bit that's set, right? Now, what's interesting about this is actually something the processor can sometimes actually just do for you. It's called a bit scan, right? And basically, like, well, you know what? I can even probably search for it here, right? So if I look in here and say bit scan forward, there we go. if I take a look at this here, you can look at MSDN. It's actually compiler intrinsic. The compiler can actually emit instructions for it. Basically what it says is it'll search from the least significant bit, right? Which, if you remember, if I was least significance at the bottom, right? So this is we're talking about the bit here. This is the most significant. This is the least significant bit. This is the most significant one, right? In our 32-bit value. So this is bit 31, and this is bit 0. Okay, so basically if we do bit scan forward, what we can do there is we can say, okay, what I'd like you to do is give me back whatever the position was where the first bit was set, right? So tell me which bit was the first one set, which is kind of what we want, because up here somewhere we've got 8 bits set, right? Somewhere. And we want to know how far to shift them down so that they line up right here, so they start here. And so really what we're trying to do is we're trying to do a bit scan to find where that value is, right? So we could implement this ourselves, obviously, right? We could go ahead and actually search for it. So I could do, for example, I could come in here and say internal, and I could basically have, I guess, a bool 32, for example. I guess I don't really know, because the way that this processor, I don't actually remember how the actual instruction works. But it looks like the way this thing works is it basically returns a Boolean that says whether or not it found a bit at all, and then it writes to an index to tell you where that index, where it did actually find it. So if we were going to mirror the way that worked, basically, it's an unsigned char that it returns, and so I don't actually know that I care about that so much. I'm going to do a uint32 there, and then it's going to be an unsigned int that's the index as well. So basically,
so he's doing the work, right, of basically implementing from scratch the thing that the Odin BMP package is giving us for free. And as much as I want to hand make as much stuff as possible, I don't feel the need to do this, because I can look into the Odin code and understand what is going on and get the result that I want, right, out of that package. It took me a while to figure it out, but I was able to figure it out. Odin's BMP package is doing the work of what he's describing, where it's getting the RGBNA values out of the BMP file and then storing them in Odin's array, in the pixel buffer, so that the red, green, blue, and alpha values are in the place where they need to be, as Odin's array, struct understands where those values are going to be. So that way, when you call RGBA, you're getting the red, green, blue, and alpha values in the array where they're supposed to be, but it's writing them out to the frame buffer where the byte order of those values needs to change. Otherwise, we get this, we get things out of order, and the right values aren't in the right place.
It looks something like this. Bit scan forward, right? And if I go ahead in here and say, all right, I want to implement this myself, right? You can kind of see how we would do it. It's not particularly complicated, right? We just have a uint32. Well, I can actually do a bool 32 here because it's still a 32-bit value. And I can, found equals false. I can then do a search, like literally with a for loop, right? Which is, test equals 0, test is less than 32, plus test, right? And then I can do value and 1 shifted up by whatever the test amount is. And if that turns out to be set, right? If value and 1 shifted up test turns out to be set, then I will write the value of the bit into the result, and otherwise I will not. And so that will basically give me, whichever one it hits. Now, if I find one, oh, sorry, I've actually done that slightly backwards. If we're trying to look for the first bit that's set, not the first bit that's not set. So we actually, as soon as we find one that is set, we want to stop looking. And if we didn't hit one, we will write to our index value, right? So if it's a 0, we count that as an index. No, okay, never mind. No, I'm correct. I was correct the first time. Sorry, I confused my own self there. As soon as we find that the set, we're actually trying to return that index. So we just set the index equal to the one we found, and we break out. Everything should be fine, right? And I guess we set found equal to true here, so that we know that we actually found one and we can return the value properly. Now let me take a look here, because since I confused my own self during the explanation, let's actually go ahead and make sure that we actually did it correctly. So this is red shift. We pass the address of red shift, and we will basically look and see red found equals that, and we can assert red found like so. And then we'll compile that. Oh, right, we already have the redshift. There we go. Like so. And what was the problem? Cannot convert argument 1 from int32. Oh, yes, right. Sorry, uint32. There we go. So if I go ahead in here and actually step into it, what I should find is that I pass in here. I've got a value that I'm checking for. It's all the way at the top. So I'm expecting the value to basically be 24, right? So I come in here, and I keep shifting up test to see whether it actually hits against the value. It's not going to hit for the first 24 times, right? Blah, 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 blah. Well, 23 times, I should say. Turn off successful, as you can see. 13, testing, up to 20, 22, 23, and now 24 should hit. It writes back to the index, so now the index gets 24 written to it. At least that's what should happen. Let's find out. Oops, start index, right, 24. We say that we did find it, and then we return. So there we go. We've done the bit scan forward, and we say that red was found. The red shift is 24, which is exactly what we wanted. So that's the bit scan operation, but we're now doing it in a very slow way. So what we'd like to do is we'd like to actually have the processor do it. And this is the perfect time to talk a little about the intrinsics things that I keep alluding to but haven't actually done yet. So maybe today we will actually do intrinsics so that we can call the bit scan forward. Oh.
So Andrew over here posted this and said, bitscan forward looks really similar to count trailing zeros off of the intrinsics package. Counts the number of trailing unset bits until a set bit 1 is seen or all bits have been counted. So, that would make it that much easier, right, if we wanted to hand roll this ourselves. And for all I know, the BMP package could be using something like that. And this is part of the reason why I think Odin is so awesome, is that these intrinsics are part of this base library here, this base package. It's also, so I had to call like inline assembly, right, to get that read cycle counter intrinsic to be called. But I can just do read cycle counter, right? I can just call this here, and get the same thing, and I don't have to do inline assembly. And when I find the more things like that I find in Odin's standard library, both the what's my speaker remote, both the core package and the base package, the more excited I get about continuing to use the language. It doesn't, from what I checked, but it doesn't really matter since it's just header parsing. Yeah, I mean, if there's a better way to do it, or yeah, I don't know what would be considered better in this case, but based off of that to do inside of the Odin package, this whole package is being written by, where was that? Was it in load from bytes? Where is this? This is, okay, BMP OS, and then Jeroen. I don't know how to pronounce this name, but this individual is a pretty big contributor, one of the main contributors to the language. So I trust them to do a better job parsing BMPs than myself, you know what I mean? And if there's something about Odin's BMP package that didn't do what I needed it to do, then that would be incentive for me to go and chase, learning it well enough to be able to open a pull request and add that feature, right, to the language. That seems to me like what I could do that's more valuable here than implementing it all myself from scratch in my own code base, if that makes sense.
Okay. Yeah. Also, I should point out, for those of you who aren't familiar with these, there's a bunch of these sorts of things, right? So you can actually count the other way as well, right? If you want to do from the high downward to count like basically the zeros that come at the top, you can call the reverse version. So you've got there's a bunch of intrinsics that will output those sort of things that the CPU can do, but that don't really have any way of specifying them in C per se. So anyway, let's go ahead and get this working first with that. But then what I think we might do is just go ahead and do that today, so we can go ahead and move this into the intrinsics and call the MSVC version. And there we go. And we can leave this, sort of slow implementation as the reference implementation as well, which would be nice because that would basically mean that, we wouldn't have we wouldn't have a problem if people wanted to compile on an architecture where the CPU can't do that and they just need a slow version of it to make it work. That's good too. Because remember, this isn't really time critical here, so at least for this function, it wouldn't matter if you could use the slowest possible thing and it wouldn't really matter, right? So the other thing too is I wonder if I should fix the API a little bit, because I guess we can always wrap the intrinsic in our own inline. It just kind of would get kind of felt out a little bit. I could make it so you don't have to pass an address there, basically. So I could do something more like this, which is like a bit scan result or something like that, which is whether or not it was found, and the uint32 that was the index, right? Something like this, and then that could do something that looks more like that, inline bit scan result. So bit scan result, and that would equal nothing at first. Having some typing problems today, it's true. And so then when we actually go through, we will then return the result here, and we will do result.index equals test and result.found equals true, like that, and break out, and then we'll return the result that way. And so that would be a little handier than having to do sort of passing the address nonsense, which doesn't seem particularly useful to me. I don't really think there's any reason to structure it like that. I was just mirroring the way they were doing it in the other one. So now you could basically do something like this, where we basically have these. So we'll just get the bit scan results out of our mass values directly, like that, and we'll do the bit scan forwards here. And the other thing I might do, since I'm kind of in charge now,
and it's not that it isn't valuable to do it this way. I can totally see the value in learning how to do it this way, and that's why I went out of my way to do it pretty much exactly the way he's doing it, but in Zig, and using the Ziggy ways to do things versus the ways that he has to go about doing things, because he's using C and C++. But because I do think it's valuable, it's because I want to just watch it through here and see, like, is there anything that he's doing here that the implementation I've come up with on Odin, using Odin, can't capture, can't emulate. And so far, from what I can tell, there is that RGBA to do. So if we get some assets that don't work with the BMP package, maybe that's incentive for me to go and contribute and get that added. But we'll cross that bridge if and when we get there. I've never heard them named like Casey said. Probably it's MSVC naming. Everybody else calls them another way. Yeah, I think it's just, Casey's a different generation of programmer. Like he doesn't call them color spaces, right? Like sRGB versus, Windows color spacing. He doesn't refer to it as that. He just says like the byte order of the colors. That's basically all he says about it. And that's like, I guess, a more literal way of putting it. Like color spacing is kind of like a way of describing, what spaces the colors go in, I guess, versus just like, this is where the memory is. As it usually tends to wind up, it's all about memory. It's all about the bytes at the end of the day.
Microsoft, bit scan forward is kind of a weird term. Maybe I would do something like find least significant.
Color spacing and ordering is different, sure, but it's relevant to what we're trying to do here. Like they're both linked to what we're doing. Like would he call them color spacing then under a different context? Like, are we just talking about context here? I don't want to get stuck in details like this and hashing them out. Not that they aren't important, but the if that's not a good example, there are many others, right, that we could point out of Casey referring to something as, bit scan forward versus count trailing 0. Sometimes it's just names that he came up with for himself. And like a good example of this is just like how different he styles his code, right? Like all his types are snake case, and then all of his variables and function names are title case. Like it's just a very like, he came up around a group of guys that did things that way and called things certain things. And then you and me, are a good bit younger, so we're gonna basically go off of like what the programming culture it was that we were surrounded by, right, during our professional or hobbyist careers, right?
Significant 1 bit, or least significant set bit, something like that, right? Because that actually says what it is. Like bit scan forward, well, what do you mean by forward? At least now we know we're trying to find the least significant one that's set, and so that actually seems maybe a little more sane to me. I don't know. I guess it would depend on endianness things and blah, 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 but I think that might be a little bit better because at least I understand what that is when I read it. At least on one architecture it makes sense, so that seems like perhaps a better idea. So let's go ahead and do that. We'll now get each of them out, blue mask and alpha mask. So now we have found those, and now we just shift those by their indices, like so, index.
I see what you're saying. Color spaces, RGB, HSL. I don't know, is that, would you say OK Lab to pronounce that? And so on. BGR is the same as just RGB, just bytes reversed. Okay, well that makes sense to me. So maybe thinking about this in terms of the color space with like this here, because I'm just going off of the context in which I'm coming across this, right? And the color space seems to inform the byte order that the color values are stored in, right? Like if we were coming across a different color space, maybe swizzling wouldn't be the answer. Maybe the order is different. Maybe this order is not informed by the color space, right? That was something that I was trying to make sure I understood, and it seemed to line up to me, right? Because ARGB, like you're saying, is sRGB backwards. That's the order that the bytes are going in, so we're, the way that we're swizzling this, right, has it going in the order we need it to go in. I don't want to get, because I am like very new to this particular domain of programming, right? So I don't want to speak out of turn. Like if I'm calling something wrong, I do appreciate being informed, what the right way to refer to something is as, but I won't pretend to know something I don't know. I am going to, if I say something wrong, it's just because the context in which I am learning all this stuff might be informing the incorrect like definition, but it's my understanding that, these things kind of go hand in hand, so it's hard to untangle them. But like I'm building an intuition here, and at the same time I need to come up with like definitions so I can communicate about these things. So I do appreciate being told when I'm referring to something as the wrong thing.
Index, 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 and we can also do an assertion on each of them, because basically we're not supporting loading anything that doesn't have all of these channels at the moment. Maybe in the future we would, but for now we want to at least ensure that we don't actually accidentally load something that doesn't have one of these channels. So let's take a look at where that puts us on the scale of fixing our color problems. Hey, it looks exactly right to me now. The only thing that we're not handling now is, of course, the alpha blending around those the edges and on the background, and that's the next thing that we have to do anyway. So that seems like a pretty good thing to do. I'm going to go ahead and say, though, that since we've got a fair bit of time here, I'm just going to go ahead and give the intrinsic thing a shot, just because it's about time that we started talking about those sorts of things. We don't have to do very much. It's not very complicated. It's a very simple thing to do, so it might be a good one to start with. So basically what I want to do in here is I want to move this bit scan result. I want to move this out, and I want to move it to here, right? And so what I want to do is be able to have this function such that if we are on a compiler that can do it really quickly, it will do it. And
keep cutting Casey off, but now you've got me spun out into this interesting path here. I'll dig into this more. That is not... Why is that not letting me copy that? Oops. I'll dig into this article more later. But, I mean, I recognize HSL... right, and HSV. I've come across these things in like over the course of doing like video editing with Sony Vegas, right? And so through playing with these things, so is this, I don't want to go too far off on this tangent, but this seems to do with like the representation of the bytes meeting. So the byte order is one thing, but the color space is what those bytes represent. Is that the right way to think about that and put that? In which case, what I'm really driving at, what I really want to have a good understanding of is how do I know what manner in which to swizzle these pixels if it's not the color space that informs that, right? Because if it's not the color spacing that informs, right? So this is just telling me that the representation of the pixels are sRGB. Is it just going to be the operating system then that is going to be like? Am I going to have a when Odin OS? I guess it wouldn't be. Yeah, would it be? It would be like a switch on the Odin OS, right? That would inform, because maybe it's just down to the operating system, the byte order that things need to be in for it to render out in the way that I want it to render out. Maybe it's just something that I got to spend more time with, and it's also why I'm, trying to let Casey do his thing. So there's too much to learn, too little time.
And not have to go through this for loop. It'll instead just tell the processor to basically tell the processor to do it, in a much more expedient way, if that makes sense. So really, what I need to do here is I need to be able to figure out whether or not, basically whether I'm on what compiler I'm on, if that makes sense. And as you know, as I said, I talked about quite a bit at the beginning. You want to keep all of your stuff segregated as much as possible in terms of keeping platform code out of platform-independent code, right? So you'll notice that we buried everything inside Win32 Handmade, and you'll notice none of this stuff leaks out into our main code. All the Win32 specific code is all in here, right? But there are limits to what we can do there if we don't want to sacrifice performance. Like what I could do here, right, is I could call a function back in the platform layer that did this operation, right? And that would keep it, and I could even pass in a pointer to that function so that it was completely isolated. I could do all kinds of stuff. But the problem is the only reason why you ever care about intrinsics in the first place is for performance. If we didn't care about performance, we'd just run this for loop, right? So the intrinsics file, the whole point of this intrinsics file is going to be, this is the place where we make a compromise and say that this is the place where we allow to do platform-specific stuff that can be directly included right into the code of platform non-specific stuff, if that makes sense. And again, the only reason we're doing that is for performance.
Sorry, I can't help myself, but you had me curious, so I started digging into the BMP package, and they're totally using trailing zeros and count ones as well to deal with the bit masking stuff, to be able to get the RGB values out into those the buffer, and the way that they should be represented in the Odin array, right? That you get back the pixel buffer, the buffer of bytes that represent the pixels in your bitmap buffer. They're totally using those intrinsics. So you were right.
If we didn't care about performance at all, if we literally just had no performance concerns, then there would be no reason to do this. There'd be no point. You would just always do things the way we had been doing them. But in the case of intrinsics, which you're only using really when you're caring about performance in the first place, this is where that sort of stuff comes in. And so what you want to do is you basically want to have it isolated again. Even though you're sort of saying it's okay to mix things up a little bit here, you still want it as isolated as possible. And so you want to basically boil it down to like a file or two that have compiler switches in them and that bring in that sort of non-independent parts of the code, right? So that's basically what we're going to do here. So what we're going to do is basically say, if the compiler is MSVC, right, then we know that we can issue this thing because this compiler happens to support this bit scan forward thing, right? And we want to do from LSB to MSB, so we're basically going to call this one. We know that in this case we're scanning a 32-bit value. So basically what we're going to do here is we're going to call this bit scan forward. The result found is going to be equal to that return value. We're going to pass the address of the index that we wanted to be set, and it'll set it, and then we're going to pass that value. And so that's just going to allow it to do it right there. We're going to make sure this is marked to inline, so hopefully if the compiler isn't dumb, it will go ahead and say, oh yes, we can go ahead and inline this directly and turn this into a instruction, right? So that's about all we have to do there, but we have to do this compiler determination. And so I'm going to go back to our Handmade, I believe it's Handmade platform, right? Yeah. In Handmade platform, what I'm going to introduce at the top, kind of like, we have this sort of basic, this is like the basic setup for the code. This is what has to happen in the code. I'm going to do a little thing here, which basically says, compiler MSVC is 0, and maybe compiler LLVM, because I know those are the two things at least that we will compile under, right? And what we will do is we'll sort of do an if here on some kind of thing. Basically, if not compiler MSVC, I should do it this way. If and def compiler MSVC and if and def LLVM, like this. I could write these out a little bit more cleanly so you can kind of see what they're doing. It's a short, if and def is like a shorthand. You could do defined that. So what I'm going to do is if the compiler variables, and maybe I'll even make a little section here like this, and this can be, note Casey types. Like this. Thank you, Emacs, for indenting me. It's finding the C++ bracket there, doing the indentation, which I didn't actually want to do. What are you going to do? Compilers. So basically what I want to do here is I want to basically say, okay, if the build system, whoever is building us, our batch file, whatever, if they want to explicitly set what the compiler is, then we'll just let them set it. So basically we're only going to set these if they're not already set. So we're gonna clear them to 0, or actually I guess what we could do is if they're not already set, right? Then what we do is at the end here. No, I still need to do this. So we need to do something like if the compiler is not set at all, right? If we have no compiler set whatsoever, right? This sort of thing. Then inside here is where I'm going to actually try to determine what the compiler actually is. So if neither of the compiler things have been set by anyone, then I'm going to go ahead and try to see what the compiler actually is. And MSVC, for example, will automatically define something that tells us what it is. I don't remember. It's like MSCver. I mean, I think it's something like that, but I want to actually go see what it actually is before I make that proclamation. Underscore MSCver, yeah, underscore MSCver. So basically, I want to do that and say if that's true, then compiler MSVC equals 1, right? And then what we'll also do is we'll do an else here, and in this case, we'll just assume it's LLVM for now, but we'll put it to do here, which is basically like more compilers or something, right? Maybe even like that. And so eventually we'll do something a little smarter than that as we go. But right now we're only compiling on MSVC. So for now, that should be good enough. So when we actually do that, let's take a look at what happens here. Oh, right, we have to undefine compiler because we define.
I know I don't have to care about this using Odin, but at the same time, I want to watch it because it gives me a better appreciation for why Odin and Zig are doing a good job at what they're intending to do, right? Which is trying to be the successor to C, so the fact that I don't have to deal with stuff like this is good, but I need to understand where I came from, right? Like I want to understand what the giants that I stand on the shoulders of had to do to get us to where we are now.
It to 0, you can't just change it, unfortunately. You got to undef it first, like so. And then I got one missing endif, so then there's an endif there. All right, so now it's claiming that bit scan forward is not defined, and that may be true. Let's see what has to be defined in order for that to exist somewhere. Let's see. Well, it looks like we just need to do that, or do we actually have to pound include intrin.h? I'm not actually sure if we need to do that or not. We could take a look. I guess the first thing we could do is try this first and see what it does. So if we are defining MSVC, we can basically now have our little section where we do the things that we want to do if MSVC is here, such as that pragma. Intrinsic function not declared. So okay, so I guess we have to include this file as well, which is the intrinsics, and then we'll see.
Like it further reinforces why using Odin feels so awesome, because you get to just go do the thing, right? Like I don't have to muddy about with dealing with different compilers or what operating system I happen to be running on.
Okay.
Other that won't come up sometimes. Like again, I still want to know, I want to understand for myself what is the right way to go about handling a case where, why can't I do this? I'm in the wrong place, that's why. I just keep going back and forth inside of the package, so let's get out of there. This right here is really what I want to have a good understanding of. And in fact, until I do know for sure that I need to do this, I'm just going to swizzle it in the way that I know works with the assets that we have, and then I can introduce myself to this topic if and when we get an asset that this doesn't play well with.
Scan forward. Cannot convert argument 1 from uint32 star to unsigned long star. Why not? Types pointed to are unrelated. Is that really true? Why would those be unrelated? I guess unsigned in and unsigned long are technically different types. Oh, the mysteries of C++. I've been programming it for so long, and yet things like that always still confuse me. I'm like, what actually do you believe the technical difference to be between those types? And I have absolutely no idea. Oops, put that in the wrong place. There we go. So I believe that should probably work. Let's find out and see if it does. And hey, guess what? It does. And now let's take a look in there and see what it actually did differently now when we step into it. So if we step in here, you can see that this is actually using this line that we talked about. And if we go to the disassembly, we can take a look at what it does. So essentially what happens here is, do you see this BSF? That's bit scan forward. It's literally one assembly language instruction that does all the work of that for loop. Now don't let that fool you, because assembly language instructions can still take a while to execute sometimes, but the point here is basically that like that is so much more concise certainly to the processor, and it's probably going to be much faster than if we were to actually have to code the loop ourselves, because if this is executing something in microcode, that's still going to be a lot faster, right? So basically what happens here, in fact you can even watch it work, what it's going to do here is going to move the value, this thing right here, it's going to load that value into the EAX register, right? And that's this register right here. It's a little confusing because we're in x64 mode, which means that it uses RAX to denote the AX register because it's 64 bits long, but really what we're talking about is we're talking about the bottom portion of it here, right? We're talking about the bottom 32-bit value. So when we do that, you see how it loaded it in there? There it is. It just loaded it right there. And now it's going to call that BSF function on the value in the register to load it out, right? It goes ahead and does that, and the destination is also EAX, so it's going to write the result back in there, right? And you can see that it wrote the result back in there, and that's the result that we were expecting, right? That's what we wanted it to actually have. Again, it's in hexadecimal, which is why it looks like an 18 instead of a 24. But you know, that's just well, you know, I can here you go. So OX18, right? You can see that that's just the hexadecimal encoding for 24. So there it is. And then that is the entirety. That right there did like the entirety of this loop, right? So that's intrinsics in a nutshell. They're really pretty simple. And basically what we want to do is we want to do those for anything where there is a convenient CPU instruction so that we can access it, because we don't want to go around, especially when we start getting more time-critical code, we don't want to go around wasting a lot of that stuff that the processor could do for us by obfuscating it. Now, it's possible that the compiler might have actually been smart enough sometimes, depending on the compiler, to actually realize that this is a bit scan forward, but why make it do that when we could just go ahead and say this is exactly what we want, right? And so now we've done that.
It seems especially important to me to understand what I'm doing if I'm not writing it myself, because I don't want to take it for granted that I can just call a thing and it works, because the second that my use case doesn't apply to exactly the way the thing works that I'm calling, now I'm completely lost and I have no idea where to begin to start you know, figuring it out for myself. And it's like a reminder that, yeah, you get to just call these nice intrinsics procs off of the base package of Odin, but you know, understand where this all goes back to and all of the headache that we had to go through, that this industry had to go through, you know, these professionals had to go through to get to a place where we could have something as nice as Odin. And also, like you said, I think that was a good point. Here in the code, I dropped this assert, you know, so that we're making sure that we are going to get something. We're always going to have an asset that is in the sRGB color space. Again, I don't know, but maybe someday we'll work with something that isn't in that color space. I don't know if it would be a BMP, like somebody, it might have been you, Andrew, who was saying to look at the QOI format. If and when I ever start messing with my own assets, it's more likely that I would just use, you know, programmer art, they call it, right? I would just do some dumb pixel stuff, and maybe I would store it in QI. Maybe I would store it in BMP just to be able to read it in with this load BMP proc, but who knows? We've got a long ways to go before we can really start digging into that sort of thing.
And we're in good shape. So now we're loading our stuff, and we're pretty happy. But if you actually take a look at what happens here, you'll notice that we would like to be able to composite this guy on top of things, and right now we're not actually doing that. And so that brings up use of the alpha channel, which we should talk about now. It's actually very, very easy for us to make this work. You know, well, you know what I'll do first? I'll basically show you the really simple version first, and then we'll talk about it a little bit. So as you know, the alpha channel, right? If you remember how this is, how this works, in the actual art tool, let me see if I can actually, how would I do this? I'll go to Handmade Data Test, and I will load up that hero front head. There we go, edit with GIMP. So if we look at this here, you can see that basically you've got, you know, your red, green, and blue color channels, but you also have a fourth channel, and that channel is called the alpha channel. Now, most people probably sort of, you know, even if you don't know exactly what that is, you know intuitively now what it is because you've probably seen it in paint programs. Like, you've probably worked with it before, right? And so if we take a look at the channels dialog, let's take a look here inside GIMP. There's a channels dialog, right, which is this. you can actually see, I can turn off the channels, and we can actually see the alpha channel by itself, right, instead of the other channels, which is basically all the alpha channel is it's basically just something that says where the image exists and where it doesn't. And it's got partial values around the edges that basically say, well, it was transitioning at this point, right? It was transitioning, it's anti-aliasing that edge, basically, right? It's giving a partial value because the shape obviously can't be, it is not perfectly pixelated. The shape was actually supposed to be a smooth line that went through there. And so these alpha values are basically there to kind of smooth that out and to sort of give you that gradual fall off, so it's not a hard cookie cutter edge, right? It just kind of feathers the things into the background for you. That's the way the art was set up to work. So right now we're drawing those red, green, and blue channels, but we're not doing anything with the alpha channel. And obviously, since the alpha channel is the only thing that tells us where the image exists, we need to start doing something with the alpha channel to display the person such that, display things on top of other things so that like bottom layers show through upper layers, right? And so inside our renderer, this is going to work, well, yeah, I won't say how it's going to work in the renderer necessarily. That's a little premature. So let's not say that word. Let's say a different word. What I'm actually going to say is not that. What I'm going to say is, let's talk about one way we could easily implement this for our testing purposes. For our testing purposes, what we can do is basically do exactly what Photoshop or anything else does, where we basically just think about things in terms of layers. We could draw something first. We could draw down, you know, our trees or whatever in the background, right? And then we want to stick a guy on top of that. What we would do is we'd essentially think of creating a separate layer, right, which has our guy on it. And basically what we'll do is when we draw that layer, we'll only draw in the places where the alpha channel says there was actually a shape, and we won't touch what's underneath in the places where it's not. So we'll basically do compositing very much the way you would think about it in Photoshop, where you have one layer and you're basically drawing layers on top of each other, and you just don't draw where the alpha channel says there isn't anything, and that gives you the show through. So it's basically like, it's like taking pieces of paper, cutouts, and stacking them on top of each other. Wherever it was cut out, you can still see through to the thing that was underneath, right? So that alpha layer, the alpha channel is basically telling us where to do the cutout. It's basically what tells us how to do the cutout. So how do we actually implement that, right? Well, while we are drawing, right, we basically have something, you know, we've got our trees, you know, they're there, and then we've got our guy, and he's got the alpha channel on and it says where things exist, and basically it's 0 everywhere where he does not exist, it's 255 everywhere that he does, and at the edges, it's somewhere between those two values, right? So it's basically a brightness value, you might think of it, between 0 and 255 that says what, you know, how much he exists at that particular point. So what we would like to do, right, is we'd like to think about that essentially for now as an opacity value, basically, to say how much of the guy blends through. And by the way, we could use this alpha channel as well for partial transparency. Like if we have something that's supposed to be sort of ghost-like that we want to sort of only partially blend on, just like in Photoshop, how you could paint the alpha channel to be some middle value, like 128 or something, that's partially translucent, we might want to do that too. So what we'd like to do is use this value essentially as a way of blending in between the two, right? So I don't want to talk about that yet, because let's just do the simplest possible thing. Let's do something that, just for starters, uses 0 or 255, or sort of rather on or off. So we'll basically say if it's 0, we won't draw anything. And if it's 255, or sorry, if it's anything from 1 to 255, anything in between, we will. I guess another thing we could do is say 128 is the cutoff. So basically anything less than 128, we won't draw. Anything greater than 128, we will draw, right? You can pretty much see how we could do that very simply, right? Because we're iterating over all the pixels of the guy in our draw bitmap routine, right? We iterate over all the values here to do this dest plus plus equals source plus plus, right? So what we could do instead is we could go ahead and change the way this works. We could do both. We could always do both advances, right? And we could isolate just the copy like that. And what we could say is, if that source value, the source part that's coming in, extract the alpha, right? We shift it down by 24 to get just the alpha by itself. If that value is greater than 128, then we do the copy. Otherwise, we don't. Make sense? Right?
Okay, I'm just gonna do it real quick and continue to make use of Odin's array programming, just because I think it's exciting that finally get to get my feet wet with this. But see where he's doing the shift out to get the alpha and then compare it. I'm just gonna compare the alpha channel off of the source buffer. So, and I guess I could actually just do, because this is just like the destination and source pixels. So I guess I could do this like this pixel. Probably don't need to do that for the destination actually, because we only pull out well, how did that happen? Just was not paying attention at all to what I was typing. I was thinking too far ahead. So yeah, I don't think we need to pull that out, but we get the destination index and the source index, and we only need to calculate this if we actually want to write, right? So we say if source pixel dot alpha, actually this isn't going to work because this is a U32, right? So I'm going to have to cast this to a U8 array. I have to wrap this whole thing here. Whoops. Yeah, so maybe shifting actually was the way to go because I didn't consider having to cast, but I think we're going to have to do more work with this, so I'll just stick with this for now. So if this value, this alpha value is greater than 128, then we can write that out. Destination index equals source pixel. Actually, yeah. So instead of doing this, yeah, we don't actually need to make that a variable. Well, we want to make it a variable, but we don't want to call it, we don't want to assign off of that because we have that value right here. I think that's probably fine. But maybe, you know, more work than is necessary. It actually does look simpler to just do the shift. Now I'm just getting over eager, but you don't know what it looks like until you actually write the code. You know, I envision, oh, it'll just be fun. I'll use array programming at every opportunity, but I don't know if it actually makes sense to do here. It does make it more explicit, right? Instead of looking at this shift and trying to intuit, okay, shifting 24 over, getting the alpha channel out. Okay, I get it. We're checking to see if we want to actually draw this out. Yeah, I don't know. I'll just leave it in for now, and I'll think about it. I'll think more about it. And then, yeah, this just dereferences implicitly, and I think that should be good to go. And clearly I did something wrong there. Let's see here.
So if we did that, and we ran it, we now get much more of what we'd expect.
Yeah, so I definitely did something wrong. No. No. Maybe it's because alpha is not where I think it's supposed to be. Okay, so that definitely did something. Yeah. Source definitely is a U32, right? Yeah, so... Huh. I wonder if... So this is basically saying if... any one of these color values, right? So we're basically missing a bunch of colors because a lot of these color values are not intense enough to show up. I guess I could just try doing it his way and then see if that works. And then I need to examine, you know, just how wrong my understanding was of what was going on here. But basically this should work, right? If I shift that. And if this doesn't work, then there's something else going on here. Yeah, so something else is going on here. We're just not getting the alpha out correctly. Or it could have something to do with the fact that we have to add an alpha channel to begin with to the to some of these. I don't know if it's all of them. Well, it can't be the guy, right? That asset, the hero asset, has to have an alpha value because there's all that transparency around it, around the head. So I don't think that's it. Yeah, I know for a certainty that the BMP does have alpha because I'm using the same one that he has, right? And his has alpha. Am I certain I want to overwrite the alpha channel? Well, yeah, because if I look at this code here, it sure looks like he's just taking the whole pixel, right, from the source buffer and overwriting the destination. That seems totally reasonable after comparing to see if the alpha value is greater than 128. Very odd. Source pixel.a. So I think these are just doing the same thing, right? What are you complaining about? Got an open paren I don't need. So this could just mean that the actual buffer, the values in the buffer, are incorrect. And I mean, literally, that's what we're seeing in front of us right now, right? But the alpha there certainly looks 0, right? Otherwise, it would be white around the edges of the guy. And he also had the same exact result as us before he made that change. All right, if I go back, and actually he doesn't show it before he makes the change, but before he made the change, our output to the screen, to the frame buffer, looked identical, where we have this black box around the head. Darn. And we saw that this works if we try on a different channel. You know, if the red channel... Oh. Okay, I get it now. Yeah. Yeah, the alpha is up front. That's all this is. But I don't want to swizzle on the R value, right? Because we mean to swizzle on the alpha. So it's interesting. It's almost like we want two buffers, right? One where the order is laid out in the way that we would access it to get at a channel, and then one where, like, just reading it straight out would present correctly. I got to think about that. I think this might have been what you were trying to tell me earlier, Andrew, about the fact that we still need to swizzle things in... Well, no, this seems pretty odd to me. Go back into our load BMP code. Why did I jump over that? Or no, this is it. Yeah. So we assign the pixel to be BGRA, right? In BGRA in the order that the pixel is coming out from the buffer when BMP loaded in it, the BMP package loaded in the buffer, right? I mean, I think for now we just got to press forward and get stuff done, but this is obviously going to cause confusion for me if I can't get the alpha value that I intend to get. And I could have sworn that I tested the R value, but maybe I just tested B, G, and A. I tested every value and got stuck on this because I didn't bother testing the R value. That was what I was trying to check, is if it just didn't make any sense to me that we didn't have the right alpha value, right? Somewhere in that pixel. So ABGR, maybe ABGR. Like, this is telling me... So the way that this is laid out in memory in the pixel that we're pulling out, is that the alpha value is up front. So maybe Odin gives you the first value in memory. Yeah, no, this is really playing with my head because I totally expected this to be right. Because when we load the BMP in, right, it should be slotting every value into its correct place. But I think that's just an incorrect assumption because when we ultimately go to present the frame buffer to SDL and we tell SDL to draw this thing, update window, there might be something like when we open the window or when we create the texture where we can tell it maybe to even use a different byte order for the coloring. This is just kind of expanding my brain. I'm trying to expand my brain a little bit so that I can think about like where in the whole process, isn't there like a create texture? Why can't I find that? Yeah. So yeah, I mean, this is it right here. The alpha is up front, and therefore when we go in load BMP, regardless of the order that we're swizzling it in to get things to present correctly, when we go to draw it out, over here, right, the alpha is up front. I think that's what's happening. So the way it's laid out in memory in Odin, when we try to access the red channel, we're getting the alpha channel actually moved up front. Yeah. It's just weird because in that load BMP code, I'm sorry I'm getting hung up on this, but I really want to make sure I understand what the hell is going on here, right? The alpha is at the end, right? We're swizzling the pixel, and the alpha value is at the very end, right? It's not over here. It's not up front. We have the blue value. I think this must be just be the way that Odin's array swizzling works, right? Like as we swizzle more dimensions of the array, we're actually getting to the bottom of the byte or the bottom of the color, right? So basically, well, no, that doesn't make sense because then, yeah, if that was the case, then calling A would give us the value we want. I need to spend some more time sitting with this, but I think the point is the A value is up front in the pixel when we pull it out. It doesn't make sense to me how we got to this point when it sure as heck looks like it's at the end of the U32. Is swizzle scope dependent? Yeah, that's what I'm like trying to understand. Can I create an RGBA buffer in SCL? Yeah, that's what I was... Well, I think I might have tried to do that before. And I don't know if that was an option. XBGR. Well, kind of looks like it is, but this mess things up when we go to write the bitmap into, or when we're reading the bitmap. I don't know, but let's go look. Whoops. Let's go look at the source pixel again. So this is giving us the result we want. Let's go back into the main platform code. And I guess I can't remember. See, I think if I change this, it might mess other things up, right? Because all of our other colors are all working a certain way. But we can certainly mess with this and change it and just see what that does. So if we go down here, there's definitely RGBA. I say we'll just go for it. The thing is, yeah, I don't know. There's a couple different things going on here, and I'm a little bit worried that I'm about to mess other things up by making this change, but if I do, it's not like we can't just roll it back. It's fun to experiment anyway and see what happens. Yeah, so that did mess some things up. But, well, yeah, so we're in hell again, which is one thing. But I wonder if do I want to go down this rabbit hole and try and figure this out? This might be something that I just have to deal with off stream. Pixel BGRA just gives you an array with those pixels in that order. Yeah, but we're assigning that to the value in the memory of the pixel buffer that we're storing in the bitmap struct. So the order should be changed to where that alpha value is now up front, or so I would have thought. But yeah. But this does, well, actually, no, this is still wrong, right? Because we should have a big black box around our guy. But we're accessing the R member of the array. And it's still cutting out that alpha. So something is messed up here. Something is really messed up here, and I just need to investigate. But we're almost done with this day of code, and I want to wrap it up, so. Try pixel.bgra equals pixel. Oh, interesting. So just dereference it and assign it the other way, is what you're saying. And you know what? I think that probably solves it now that you mention it. Let's back this off. And yeah, it's saying, well, I guess, yeah, it can't hurt, right? I don't think it can hurt to try rather than speculate. Yeah. Not identical. Yeah, it's interesting. Like, does this give us back a whole new array? This is kind of what I was wondering about before I tried testing the change. Like, if we change this, if we call this member, right, this swizzled member, I think it might be giving us back a whole new array. And so it's not going to change the underlying memory, even if it did work. Even if it did work. I don't know. I appreciate you guys putting on your thinking caps and trying to help me figure this out, but I don't think it's a problem that unless it's obvious to somebody, right? I don't think we're going to solve it, and it should be obvious to me because it's my code. I'm the one that's been staring at this, so I wouldn't expect anybody else to just look at it at a glance and make sense of what's going on. It just seems really odd to me, right? Because we're modifying the memory, we're modifying the color with the 4 bytes that we're assigning back to the pixel in memory. And so it should give us, you know, the red value in the first channel, the green value in the second, the blue value in the third, and the alpha should be last in the fourth. And so when we call, you know, A on the pixel, so I'm glad that I discovered this, even though it's not having the outcome. We're not getting the output we expect when we do this. It's good that I discovered it because it means there's some other bug. Right? But this is what we need to be able to do. We need to be able to reliably say, give me the alpha, because I want to multiply alpha by, because otherwise when we start doing array programming and we're multiplying a bunch of vertices, you know, back and forth to do like linear blending like we're going to do, we're going to run into some confusion, right? So, well, I guess one thing that I can do now that I think about it, is we could swizzle the result that we get out of the cast so that when we go to, that might be just the sanest way to do this. So like if A is up front, then we want R, I think it probably just goes ARGB, right? So that doesn't make any sense to me, because this would just be calling it like in order. Isn't that how Odin's array stuff works? RGBA, yeah. So the alpha is first. Oh God. Like, would it be like this? No. No, because the alpha is first. It's just super strange, man. So this shouldn't change anything. What's going on now? Because we're getting a pointer back. Yeah, we need it to be a pointer. This is so bizarre. I was just going to leave it to do, but now I'm like, can I just assign? Because we're going to do some more stuff here where we got to swizzle some things. What if I just do this? Let's just do that and see what happens. Oh my gosh, I am so sorry for what just happened right there. That was not supposed to happen. Pixel.bgra gives you BGRA only if you assume pixel is an RGBA. So pixel.bgra equals pixel should have been backwards from BGRA to RGBA. Strange thing that it didn't work. Yeah, like we're getting messed up color values when we output just the straight pixel. So anyway, I'm going to play with this on my own time. I just want to get through the rest of this day of coding because I'm running low on time. I got to wrap up the stream soon. But yeah, we will add a to-do. It's going to be confusing, I think, to get through the rest of this coding, but I'll hopefully figure it out. Figure out why actual, channels are not lining up with the Odin's array programming. I don't know how else to describe that. So let's just keep moving forward, and hopefully the answer will reveal it to myself. God, I can't talk. Hopefully the answer will reveal itself to me so that I can describe what the hell was going on here in the next stream. BGRA maps to RB BG GR AA. So backwards would be GRBA. Huh. I guess I would have expected that to just swap the B and the R. But what you're saying here is that yeah, if the alpha is in the same place anyway, then why is it coming out of the red channel when we go to call this? I'm sure other people run into this sort of thing too, so I bet if I look on the Odin Discord, because I haven't really looked at array programming at all yet, but if I start looking for examples of stuff that other people have come across, I'll probably find something that helps explain things, or at least gets me closer to an answer. BGRA returns a new pixel, but new pixel.a will return pixel at index 2. Or do arrays in Odin always remember that it's been reordered? I would think that the array remembers it's been reordered because we've reordered the memory in the buffer that way, right? When we go to load the BMP. That is why I just expected it to work, right? Because if we don't do this operation, we get this blue, the blue and red channels are swapped. And so that's why, Like if you were to access it just straight out of the memory in the way that it's ordered, this is what I would think you would call RGBA, because that's what Odin's own overview here says, right? Yeah, right here. Built-in implicit swizzle fields are available on any array with length less than or equal to 4 as X, Y, Z, W and RGBA. So R would correspond to the first, G would correspond to the second, B would correspond to the third, and A corresponds to the fourth. Now, maybe that understanding is correct, but I mean, you're calling them in this order, so you would think that's the order of the indices. The buffer has been reordered, but the buffer doesn't know what's in it, so it wouldn't assume A is still the first item in the buffer. I think it would assume based on the memory order it's in, but I guess I hear what you're saying when we do this, but we haven't changed the alpha, I guess is the whole point of what I'm saying, right? The position of alpha is the same regardless, so you would think, yeah. Anyway, as much as we could probably, A is always fourth, it doesn't matter what happens with the buffer. Yeah, like, and for that exact reason, right? Why on earth does accessing pixel.r, why does accessing R give us the alpha value? We're not storing, our alpha is not stored where we think it is. And it's very confusing. But anyway, like I said, I'll try and figure out what's going on there and get an answer by the next stream, hopefully. My bookmarks out of there. Meant to switch back to here. Yeah, so this is just something to figure out on my own time. And I promise I'll have a good explanation whenever I figure it out.
As we don't. Make sense? Right? So if we did that, and we ran it, we now get much more of what we'd expect to get, right? We now get something which doesn't draw the guy everywhere where he had an alpha value less than 128, and it does draw the guy everywhere there's a value over 128. And all we did was just add that one simple test, right? That's all we were doing. Now what you'll notice is it has a very hard edge around it, right? If I was to do the zoom in on this, right? Let's say we go into Krita there. I don't actually know how Krita works here. Can I do a paste as new image? Paste into new image? I don't know what you're asking me. I don't know. I don't really know how to use this program. Oh, is this what I want? I don't even know. All right, yeah, I guess it is. It's doing what I wanted. Okay, good enough. So if we look in here, you can see, there's a lot of anti-aliasing. This is very smooth graphics. There's a lot of anti-aliasing everywhere in here. There's a lot of kind of, blurring of those edges to make them a little smoother. That's kind of the way the art works. But
I don't know why I couldn't do this before, but I'm just looking at this again. Okay, it's saying it's not identical. Because one is a pointer. Okay, yeah, I needed to dereference this that whole time, right? Again, that is just... Why is that creating... Oh, it's because sometimes... Oh, yes. Well, maybe this fixes that then. Nope. Good God. I think that I can work around this problem I'm having by figuring out how to do this correctly, but anyway. Copy it to another variable. You change image every draw call. I guess there's that. Yeah, because I'm dereferencing the whole thing. Yeah, that's a good point. So, good pixel, as in it's good and it's laid out in the way that we expect. You gotta declare it. There we go. Now what the hell is your problem? Is it because we're not dereferencing this? Yeah. Interesting. So what this is doing is it's giving me ARGB values out of like the pointer. I would have thought that the implicit dereference would have worked just like that, but you have to dereference the pixel. And so actually I think that this should work, right? Whoops. Well, this is, yeah. Because it's not a pointer. I mean, I guess I could just say, give me the address of all of that. Cannot take the pointer address of etc., which is a swizzle intermediate array value. Okay. Clearly I'm trying to be too clever. Let's just leave it as a good pixel. Throw the A up front. Now we can call on the A value and we're okay. Oh man. I've been humbled many times on this stream, and I'm sure that wasn't the last.
When we get to this guy, you'll notice there's no blending there at all. So it's a very hard pixel edge along the guy. And the reason for that, again, is because we're not using any partial alpha values at all, right? We're not doing anything to try and use those values that are in between 0 and 255. We're just making a hard cutoff. Now, what this is often called, in fact, you'd see this called this in 3D graphics a lot, it's called alpha test, is what this is called, which is basically a hard clamp limit, which basically just looks at the alpha value and says, I'm either going to do an operation or not based on whether the alpha exceeds a threshold or not. And that is exactly what we implemented. This is basically alpha test right here. But what we'd like to do is something a little bit better than alpha test. We'd rather do something that's actually some kind of an alpha blend.
And actually, I left that in as the wrong value, right? Because we want to check for 128. Well, now we are just in really weird territory, because why does that work? I mean, he has it set to 128, does he not? Yeah, he's comparing to see if the alpha is greater than 128. Oh man. That's messed up. That's so messed up. It's almost like we're not aligned properly or something. Is how it's starting to feel. But yeah, I don't know. We already tried R. What about G? What about B? Yeah, no. I do not know. I really do not. What do we just pick an arbitrary value? Yeah, and then we're wiping out these trees a little bit. The tops of these trees. So that's... yeah, that is so messed up, dude. I don't know what to make of what I'm seeing at this point.
The render at the moment, what we're trying to do is write stuff that we can use. And so what I'd rather do is just, well, you know what? No, I'm not going to talk about how to do any of the fast stuff. We're just going to do it in the slowest possible way. So what we'd like to do now is we'd like to go ahead and see about how to actually do that alpha blend. Now, I probably shouldn't spend too much time belaboring this because there's actually an entire video, in fact, of me explaining interpolation. And I don't know whether we want to rehash that entirely on the stream or just... did that just crash? I think Krita just totally crashed on me. It did, didn't it? Ugh. Yes, it did. Krita just totally just crashed. It just full on went away completely. Ugh. Ugh. Well, what are you going to do? Let's launch it back up. Come on. You can do it. It was working so well there for a while. See, I tried to make a new image. I guess the thing to remember is never try to make a new image, people. That's the rules. You don't ever want to make a new image. All right, that's fine. Make the image, please. There we go. Hello? All right. Okay. So here we go. So what we need to essentially do here, right, is I want to make something that allows us to smoothly blend between the two values. So we have a background value, right? I don't know why that's always the hand shape. It just is. I guess the hand was what they thought was good there. So I have a background color that's coming in, right? I've got a hand, apparently, that's drawing this now. I've got a background color. It's funny to have it be a hand like that. Does that help at all? Nope, that doesn't help at all. Welcome to the mysteries of the universe, ladies and gentlemen. I've got a background pixel. So this is one pixel, right? I've got a background pixel, and I've got a foreground pixel, right? This is the, I guess I'll call this the sprite pixel, the bitmap pixel that we're drawing, right? So this is whatever's in the buffer, and this is whatever's in the thing we're putting on top, right? And so in this code here, we've got a source and a dest, right? So basically, this is the dest. This is the thing we're writing to. And we've got the source here. This is the source. This is the thing that we're trying to draw down. This is the guy's head, right? So this is the trees, pixels. This is the head pixels, right? So now if we do this, what we need to do is this is some color. Let's call that color A. And this is another color. We'll call that color B. Wow, this is awful. Like, I can't even click down anymore. Ugh, I tell you. Computers these days, nothing ever works anymore. Okay, so I've got these two colors, A and B, and what I want to do is I want to produce a third color out of these, right? I want to produce a C that's some blend between A and B. And what I want it to do is I want it to blend based on that alpha channel, right? I want the alpha channel to blend it such that when it's 0, I get A, and when it's 255, right, I get B. Does that make sense? So when I actually go to do this, what I need to do is figure out some mathematical way of getting from A to B smoothly based on another value, right? I need to figure out some way to pick, because if you think about the number line, right, I've got 255 at the high end for each channel, and I've got 0 at the low end, right? Essentially what I'm doing here is I'm saying I've got 2 points on this, and I don't really know where they are. In fact, they don't even have to be in any particular order. A could be higher than B or vice versa or whatever, right? So this is, let's say, and this is, when I say colors, obviously I mean one channel. So we could think of this as just the red channel, right? Or the green channel or the blue channel, just one of them. So when I'm going to do this, I basically have whatever was in the background, whatever that channel's color was, right? That's here. And then I have whatever the new color is that I'm putting on top, whatever the sprite is, whatever's in the guy, and that's here. And what I need to do is figure out a way to produce all of these values in between here, right? I need to be able to produce all of those values based on what the alpha channel is, based on what that alpha channel says. And if the alpha channel is 0, then I'm going to leave it where it was, so I'm not going to touch the background at all. And if the alpha channel is 255, I'm going to drive it all the way to B, right? So essentially the way you could think about this, and the way that I usually like to sort of explain it to begin with, is that you can think of it as being based around one of the numbers. We can think of it as being based around the number that's 0 primal. So the number where we have 0 yields that value, which in this case is the background color, right? We can think of starting there. And what we want to do is we want to start there, and we want to sort of go some distance towards B, where that distance is going to be 255 if we went all the way, right? And 0 if we didn't. So how do we produce what that actual distance is, right? What's that value? Well, if you know rudimentary math, you already know what that is. It's just B minus A. Right? B minus A is, if you will, almost, and we haven't talked about vectors yet, but it is essentially a one-dimensional vector, but it's basically the delta, right? It's the difference between A and B, such that if I were to take A, start at A, and add back in some, this full portion, I would get B. And it's pretty trivial to see why algebra-wise, right? A plus B minus A, well, the A positive and the A negative cancel, and you just are left with B, which is the value that I said we would get, right? So this is basically the core of the thing that we're going to use to determine how to blend something, right? Because basically all I really need to do is take this expression, the A plus the B minus A, right, and say, as if I can figure out some way to only add part of this in there, right? All I really need to do is stick some kind of a percentage in here, right? Some kind of a value that's like a percentage from 0 to 100%, right? If I could just multiply this by some percentage, then I could go any percentage of the way from A to B just by changing what P is, right? A plus some percent of the distance from A to B is going to give me exactly what I want, right? So if we go ahead and build on that assumption, right? If I want to say I've got A plus some percentage here, right? And also by convention, this is often called T. I'll just point that out to you. We can use that because you'll see it use this way very often. But some percentage of the distance from A to B, this would basically give me that value that I wanted. This would be that resulting color. This would be the color that I wanted out, right? So really all I have to do is figure out how to do this. Now what you'll also notice is I can rearrange this expression in a couple of different ways. If you know algebra, which I'm hoping everyone on the stream does, because, well, honestly, I've never thought about how to teach algebra before, so I don't suspect I would give a very good explanation. But assuming you know algebra, then you also know that I can pretty trivially use the distributive property here to distribute T into this expression, and I would end up with these terms, right? A plus TB minus TA, right? And I can rearrange those terms any way I want to. So I could group them this way, right? I could group them here by just moving this term. This term here moves here, right? And this term stays where it is. This term slides there. If I do that rearrangement, what you can see here is these two front terms both have an A in it. So I can pull out the 1 minus T there times A plus TB okay? And now you have what's usually the more canonical version of what's called a linear blend, right? This is usually called a linear blend. And what it is, in either form, doesn't matter which one you find more attractive, they're just different ways of computing the exact same thing, right? Algebra, it's the same thing. All they are a way of taking one thing in, that's your, your starting value, one thing in that's your ending value, and basically being able to produce anything in between them by plugging in this percentage value here. But we haven't actually talked about how to actually make this percentage value work in practice. I just kind of magically waved my hand and said we had a percentage value here. So we now need to talk a little bit about just how that guy works, right? Well, literally in the math sense, and if you're doing this entirely in floating point math, it could literally just be a percentage, right? You know how to translate percentages. Again, if you've had high school math or whatever, you know how to translate percentages into floating point math. 100%, right, is 1.0. 50% is 0.5, right? 0% is 0, right? So the numbers between 0 and 1, all inclusive in there, are just those percentages. So really, in this expression, if t were to range between 0 and 1, including all the fractional values in between it, then no matter what a and b are, I don't care what they are, they could be colors, they could be anything, positions in space, whatever, doesn't matter, this will give us a blend between them, right? This will allow us to move smoothly between the two of them. Okay. And so if you're interested in more about this sort of stuff as well, I would also recommend, if you do want to go to YouTube on the Handmade, in fact, YouTube Casey Muratori, I think is what you would type in here. Let's see here, Casey Muratori on YouTube, there we go. You can actually see in my videos page, there is a Witness Wednesday Part 10 interpolation video, and that is a full-on 50-minute explanation of interpolation and how it works in a lot of different ways. So basically, if you want to watch that for more information, you can do that as well. So. Where are we at here? We've only got 7 minutes left. So let's go ahead and slam in the floating point version of this so that we can actually see it in action, and then maybe we'll go ahead and fix it to be a fixed point version later. But basically you can see exactly what I'm talking about here, right? So if I was to go in here and write the floating point version.
Okay, we're going to knock this out and pretend like our stuff isn't jacked up, and then I'll figure out, what's going on, again, like I said, and I'll try to determine some kind of sensible explanation, but to tell you the truth, I have no idea how long it'll take me to figure this out, because I was certain that this was working. I believed with every fiber of my being that we would just start array programming with Odin, and we'd be good to go. So we'll see what the future brings there. But does pixel.bgra take the header from the file and arrange it in BGRA format, or does it assume the file was in ARGB and reordered them in that format? I do not think that it's assuming. I think that the BMP package for Odin looks at the layout of the BMP and starts parsing it from the header, and then determines this is the byte order that the colors are in, and then it just plugs them in, which is why, if I look at the load BMP here, and we look at this here, it's why switching the R and the B worked, because I could just kind of tell by looking at the photo, right, that the red and the blue channels were swapped from where they needed to be when they were being wrote out to the frame buffer. And this makes sense because we looked at the actual SDL call where we generate our texture, and the texture is in sRGB starting backwards from here, right? We have our alpha RGB. So we're just, I don't think there's any assuming going on. I think that Odin's core library knows that we're getting in a BMP that's in this format, and then we're just trying to reorganize that memory so that when we hand it off to the frame buffer, it's getting those values in the right order that it expects them to be in, right? If 4 out of 4 channels don't work, it means no alpha is really there. There has to be an alpha there, because otherwise we'd break, right? When we're walking the bitmap in 4 elements at a time. Now, if we go over here, I can also show you that I'm making this call to add the alpha channel if it's missing. And if there is no alpha channel, it'll break the whole program. We won't run, right? Hopefully that makes sense. So there's an alpha channel, but it's a good point about, like, when we call this, is it adding the alpha channel where it should be? There's just something strange going on here to where we're not getting that alpha in the place we expect it to be. And also, like, nothing is really producing the result that we expect over here, right? Nothing seems to work, because if this is the alpha channel, and it appears to be, because when we run it, we get that black box eliminated out of, you know, the result. But then when we try to use the same value that Casey's doing, it screws us up. So again, I'll try and get through this, and I'll act as though this isn't busted, and then we'll figure it out later.
Of this, let's go ahead and see what we get, right? What I would get first of all is I gotta extract my red, right? And so my red channel is going to basically be shifted down by 16, whatever's in that source, right? And then masked off. So there we go, and converted to a float. So that's a number between 0 and 255. There we go. So then we have green. I guess I could just do R, G, and B for short, right? The green is the 8, and that's 0. Then the alpha channel, right? I just said I need it to be a number between 0 and 1. Well, this will be a number between 0 and 255, right? So if I want to turn a number between 0 and 255 into a number between 0 and 1, I need to divide by that range. I need to divide by 255. So that way 0 will map to 0, 255 will map to 1, and everything in between will map somewhere in between, right? So now I've got an AR, a G, and a B that are actually in floating point. Now I need to do the exact equation I just said. I need to create my new red, so I'll say that my red is now going to be equal to, oh, I forgot something. I need the dest as well. So I have my source R's and my dest R's, right? I've got to pull them out of here so that I can blend with them, right? So I pull out the dest R, the dest G, the dest B, and I've got my source R and source G. And to be fair, I guess I don't actually even care what these are.
So he doesn't need to pull out alpha twice. And then the dest, well, now I really should probably do this up front. So that was premature to move that index calculation out of there. Get the dest pixel out. And this isn't quite right, is it? Because I think we want a reference to it. Otherwise, we're just going to be assigning it by value. And then all of these are coming off of the dest, like that. Destination red, destination green, destination B. Like, again, I know that this is all going to be wrong, but we're just going to do the work of calculating the lerp so I can wrap up the day and then figure out what's going on later, because it could take me all weekend, and I don't even have all weekend. We might be debugging this crap through all of next week for all I know at this point, because I really had every hope, this isn't right, that this would just work. So we're going to get the alpha out, but we're going to divide it by 255, like he said. And just to sanity check, because, oh, why am I recording? Does it say I'm recording? No, I'm streaming. Okay. It gives me the little red thing, a little red circle if I'm recording or streaming. What was I doing? Yeah, let's look at that photo. I'm very sure it's the exact same asset he's using, so there shouldn't be any reason there. Like, so the background doesn't have an alpha channel, right? But that the head definitely does. Go into my data directory, look inside a test. Yeah, I'm looking right at it. And if I throw it in my browser, you can't tell, but it's definitely transparent around the head. So there's definitely an alpha channel in there. It's just, you know, we're not getting it out properly. Add alpha if missing is adding an alpha channel if there is none. And I had to do that for the test background, which is, let me comment that out. Cannot assign. We want to do that. So the head is definitely transparent. Otherwise, how would we be able to mask it out even though we're doing it incorrectly? But it's this test background texture that I'm talking about, this test background bitmap does not have an alpha channel. And so making that call to image.add_alpha if missing gives me that channel, so I can still operate it in 4-element wide colors, right? Because I don't want to implement 2 different loops that walk the bitmap, one in orders of 3, and then or in you know, in colors in 3-byte sized colors. I don't want to implement a loop that does that and then we'll do one that implement one that walks it in 4-byte wide colors. Like I just want one loop that does the work. And so that's why that proc is convenient there, because for whatever reason that image just didn't have an alpha channel. But that doesn't make sense to me then why he gets to use it that way. I think it's just because of the way the BMP is being parsed out by the package versus the way he's just reading the bytes out. I'm not sure. It's like if the channel is empty or something in the source, maybe when it reads it in, it just gets rid of it. I don't know. Not sure what's going on there. Okay, so yeah, we don't need the alpha there. And what is this error here? Has no field G. Oh, because I'm not calling that on the pixel. I'll go ahead and break that up. Do the same over here. Clean this up later. Now what? Gotta dereference all of these or what? Okay. Oh, it's because... okay. I made the same mistake twice. And this should be source replaced with dest. And there we go. Getting all sorts of turnaround here. It is so disappointing that this didn't work just out of the box. But once I figure out what the hell it is I'm doing, I feel like it's going to be really cool when it does work.
We don't even care if these are RG and B. We just care that they're channels 0, 1, and 2, right? We don't even care. So we could be wrong about these shifts and it wouldn't matter as long as we do them all. So anyway, now I'm going to actually produce my result red, and my result red is just going to be the exact equation that I just specified. It's going to be A plus T, A minus B if I wanted to do it that way, or I can do it this way over here, which is 1 minus T plus TB, right? So I can do it this way, right? Times A plus T times B. So we'll leave it that way for now, and we'll basically just say, okay, if I do one, what's my T? Well, my T is the alpha value. That's the thing that's actually causing it to work there. And then what's my A and my B? My A is going to be my destination red times my source red, because I'm trying to get to the source red, right? So that source red is the B color, and the vacuum color is the A color, right? All right, I believe that's what we said it was, and so off we go. Now we'll go ahead in and just do that for all of them. Got to move that up a bit so it's not obscured by the 5-minute warning, the dreaded 5-minute warning. B, oops, A, G, B. B, like that. And then once we're done, we have to then reassemble the resulting value back into something that we can actually use. So what I have to do now is actually do sort of that build back again for the thing that we're going to actually write to dest. So we have to actually write something to dest. And what we're going to write to dest is going to be our R, ORed with our G, ORed with our B, but we have to now turn them back into actual rounded values, right? So we have to actually round the values each time now, like so. Like that. I suppose we could just go ahead, since we know these are always positive, we could also do this as a truncation, which would be a little cleaner, right? I could do it this way, where we just actually truncate the values plus the rounding amount, like so, which I think, you know, probably is a little saner here, since we are actually doing this per pixel. Per pixel things are very expensive, so we do have to watch out even in our test code so that we won't get too slow and not be able for not for us to use it. But we may replace this. We probably don't want to be doing this necessarily in floating point math the way that we're doing it here right now anyway. But anyway, point being, so here we go. We're going to actually take these values and pack them back into the places that they normally go, right? Like so. We basically unpack them and pack them. Oops. 8, 16, like that. The R gets shifted back up. I think I've put everything in there. No, I wrote that in pretty quickly there. We'll have to step through this and see if it works. But I believe if we typed it correctly, we should have. I'm not gonna paste things into Krita anymore. Quickly there.
He's so fast. How do I be that fast? So it's just ORing, and then he's also shifting. I wonder if I can get cleverer about this and, you know, stuff all of these into a U32 and then just do the array swizzling to get at the values that we care about. But I'm thinking we'll just do it exactly how he's doing it for now, because we've already invited enough trouble not doing things the way he's doing them at this point. What are you complaining about now? Truncated to U8. Why would you do that? I guess I should make sure that these are all turning into floats. Yeah. So no way is this going to produce anything that looks remotely correct. No! How did we go so wrong? That's so sad.
Shift it back up. I think I've put everything in there. No, I wrote that in pretty quickly there. We'll have to step through this and see if it works. But I believe if we type it correctly, we should have. I'm not gonna paste things into Krita anymore. Lesson learned. We're gonna paste things into GIMP from now on. That way, if it crashes, we can still draw in the background. So now let's take a look at what happened. Can you see in here how that looks now? Where you've basically got you know, that kind of smooth, that nice smooth edge. Now that we're being the alpha channel, so that's a much nicer comp, right? That's just a much nicer thing to look at, right? And yeah, I mean, that's alpha blending in a nutshell, right? And so what kind of alpha blending actually is this? This is a straight linear blend between the two. There's other, like I said before on the previous stream, there's lots of different things you could mean when you say alpha blending. It depends on what that blend equation is, right? So basically, this guy here, this is our blend equation that we're using. There are other blend equations. So what I'll also say here is, to do Casey, someday we need to talk about pre-multiplied alpha. Because we are not talking about that at the moment. But now is not the time to start that discussion. Suffice to say, this is not pre-multiplied alpha. But I'll just leave that for a little thing that we can talk about later on, because at the moment it's really not something that you need to think about whether it's pre-multiplied or not. But it is something that we will have to think about a little later on, because it affects the math in very important ways, and we will need to switch to using pre-multiplied alpha for our final assets and so on. So since we are basically out of time here, I believe, yes, we have 1 minute left. I'm going to call that done for the day. We have our alpha blending working. Oh, you know what? I'm not going to quite call it done for the day. I might do one more thing, although I think this actually will cause us to have a couple bugs. But I'm going to go ahead and make our hero head actually draw at the location of the player now. Yeah, so there we go. So there's our hero head. Very exciting. He's not actually in the right position, but at least he moves around there with the guy. Very much fun. Yay, yay for alpha blending. We're pretty close now, so I think basically tomorrow we'll have a little guy walking around instead of our rectangle, because we're pretty close. All right, everyone, that is it for now. The Q&A has begun. Remember, I only start looking for Q.
Well, I don't know if I'll ever have time for a Q&A on stream again, but I'm glad we at least made it through the code. I'm like half an hour where I thought I was going to be able to end. I thought this was just going to be a straightforward day, and I'd get to show off some Odin array programming, and it would be so much fun, but why would I make that assumption? You know, I just got to stop assuming that things will ever be as easy as I want to imagine they'll be. But we'll figure it out, and it'll be awesome when we do. That is true. I'm watching him on ×2 speed, and of course that does make him go faster. But also, like, even if it was normal speed, I'd be struggling to keep up, as evidenced by the fact that we are almost 2.5 hours into this stream, and he was able to get all that code done and then some in an hour. I know we went on like random tangents and talked about different stuff, but even so. But to your point, I kind of feel like that's just my brain. That's how my brain thinks how fast he actually talks now, because I'm so used to watching him at 1.5 times speed. But aren't those shifts putting it in ARGB format rather than RGBA? Where was that code? It could be that that's like a big part of the problem that I'm having altogether, because he could be trying to write everything out RGBA, but I'm doing it sRGB. But I could have sworn he talked about wanting to do things in sRGB order in an earlier stream, so I'm just gonna trust that he has hopefully done these shifts correctly. I mean, on his end, he clearly has, right? It's clearly working properly on his end, and it's not on mine. But it's not, we already know it's not working for other reasons, and that is that the erase swizzling is introducing some weirdness that I need to figure out. Doing A times 1 minus T plus T times B, you can just pre-compute. Yeah, so you'll see that he'll kind of walk through that. I mean, if you have, I'm sure you've already thought about this, but I'm trying to stay 1-to-1 as much as I can so that I don't have too much variation. We could just do, the obvious thing to do, but he's going to take us there anyways. And as evidenced by this point, like, this is where my code has never been more different, right? Other than the fact that it's in a different language altogether. But I feel like it's exposing some good conversation to have about these things because the implementation has to look different. And it's giving me a deeper understanding of all of these different topics, because I have to actually understand what is the thing, because I can't do it, or rather I'm not doing it exactly the way he's going about it. So I just need to sit with this and take it one step at a time. I'll probably just, comment all this out and then make sure, right, that we can get the just that masking the alpha out if the value is less than 128, right? And just not write that pixel there, because it should mean that nothing is stored there. But you can see clearly we've got this very wrong thing happening here. And the other thing too, actually, is that I see he just takes that check out altogether. So that's, I guess we can see what the actual result is. I just realized that we're not actually executing any of that, or rather, we're not seeing this result here at all, right? So this will probably look even more jacked up. Yeah. We have successfully wiped out all notion of any sort of game here. It's a mess. But it's okay. I'll figure it out. Yeah, we're swizzling this here to get our quote-unquote good pixel. Yeah, so that, like, we can hopefully have things in the order that we expect them to be. So now I'm able to do this, check here, but this is still incorrect, right? Because it's not producing the right value. Like, so I guess we'll worry about the linear blend and making sure that I can get that working once this check actually does what it's supposed to do. Because what it should be doing, I gotta comment that out. What it should be doing is giving us everything exactly the way it should be, but with a bad kind of cropping of the guy's head out, right? And then we do the linear blend to make it look smoother. Do the lerp. And this is just all wrong. It's like applying it to seemingly everything. Like, we're not writing... It's almost as if not only are we not writing if the alpha value is less than 128, it's not like we're writing any pixel out. So, like, if I go down to 64, yeah, it's like it's changing the alpha for everything. Maybe there's just something wrong with me. I mean, there's definitely something wrong with me, but when he goes to implement that original check around the alpha, no, I mean, it's almost like it's reversed. What happens if we do less than 128? Okay, well, that's definitely wrong too. Wow. Okay, yeah, so damn. Try to put the alpha channel indes. That's a good idea. Like you're basically saying, this, right? How do we get the alpha out? Is it like this? Or is it like, well, all I should need to do, right, if I do it right, is like that. U32. Yeah, how do I get the alpha value out of a U32? Yeah, we can... I guess I could just try writing out each channel. Now what? Gotta comment all this stuff out. Maybe just turn off the unused thing. Yeah, so this gives me blue, which means do this, get the alpha? No? This gives me the red. Would it be the... No, because this would just go one whole byte over, right? I don't want to have to cast this thing just because I'm too dumb to know how to shift out the alpha. Ugh. And plus, when I do that, I won't even get the right value anyway. I'll sit with this. I've clearly got some work to do to figure out why this is so screwed up. As disappointing as it is, I'm sure it'll be a good learning experience when I ever figure out how to fix it. The question is then, will I learn the right lesson? That's the important thing to do here, because right when I think I'm getting a good enough understanding of what is going on, some other curveball gets thrown my way, and I'm screwed up all over again. So yeah, thanks for hanging out with me. Thanks for your help, and for helping me figure out how to make sense of what it is I'm looking at. Because Lord knows I need the help at times. But we'll be back on Monday. I don't think I'm going to have any time to stream this weekend, so we'll go for it next week. Yeah, yeah, well, I guess, okay, yeah, I'll try that real quick. I was going off of the whoops. Yeah, no, that still won't work either. Why is it complaining about this? Can I assign? Oh, because it's a U8. Okay, so if we just cast it to U32 then. I'm just getting so twisted up between like the actual pixel color value and then like the array of the color channels. That was the wrong thing to comment out. Okay, so that's giving us blue now. Oh yeah, because, okay, yeah, let's try R, because that's where our alpha is. Does that make sense? What if we do green? It's like the blue channel is... Why are you blue, no matter what I do? Well, I guess because it's going to the... So the end... Yeah, we're just writing the different values out to the blue slot when we do this. That's why this is happening, right? Because it's sRGB. B is at the end. When we write this out here, we're writing into the blue slot because casting this over to a U32, right? Yeah. Yeah, that's right. So if we shifted this up to the alpha spot, right? Would that then store the alpha in the place where it's supposed to go? We need it to go up to the front, but I don't know which direction to shift it in to do that because I'm a nincompoop. I don't know. Maybe add alpha if missing overrides alpha channel. Yeah, I was starting to suspect that there could be something there, but it said the name of the proc. I wanted to believe that's not the case because it says add alpha if missing, right? Don't replace the alpha channel, right? If there already is one. It's all like it says that in the name basically. So I don't want to believe that's true, but you know, we should probably make sure. Anyways, hope you all have a good weekend. Thanks for sitting in with me for some more programming this week. I can't believe this is already, what is this, the end of week 3 of doing this. Still enjoying myself, but man, am I getting the shit kicked out of me here. I did not think this would be such a pain, but it's all good. We're learning, so we're moving forward. Take care. I'll see you next time on Monday.